So I had two previous videos where, I was going to try to talk about getting Gordo6908 to Eastern Kingoms. Now the problem that I have here seems to be, kind of been putting off continuing on this because the actual concept of Eastern Kingoms as a map doesn't really fit on Warcraft 3 very well. And so trying to have a Warcraft 3 emulator and then retrofit a World of Warcraft map into that, it's kind of a joke, right? I mean, I feel like it's kind of a joke. And there really are two different ways to do this. And one of them would be to try to actually port that map to a Warcraft 3 map. And the other one would be to try to just modify the software concept of War Smash as a game and make that game open a World of Warcraft map. And I think that one of those two technology solutions has to be built to actually continue on this sort of meme idea of getting Eastern Kingoms in War Smash. Otherwise, it just isn't going to work, right? So we either have to write software to port the World of Warcraft map into Warcraft 3, or we have to write software in War Smash to process the World of Warcraft map as is, and then load it as is, more like you would see in a World of Warcraft game emulator, because the maps just are not a compatible technology format. So that's definitely a problem. And there are a couple different ways we could imagine trying to solve that problem. But I've kind of been putting off getting to it because I sort of thought, it seems like annoying to succeed. There's a lot of stuff I could do that doesn't involve solving that problem. That's kind of fun. For example, if I go to this like War Smash INI thing, open with text editor, I think I had the music turned off. We could turn the music on and then change it so that instead of, I don't know if you guys saw this, but instead of whatever it is now, what would this be? Resources, UI, War 3 skins, where we edited some stuff. We could go in here and we could change, what is it, War 3X, main glue screen, music. That music, see, we could change this to instead be whatever the World of Warcraft one is, which we should be able to figure out, I guess, using that. So this is just something I think would be fun. This is, sorry, that's the code repos folder, but maybe that's not what we want. Maybe we want to go back to WoW 3 Frozen Throne, go to this thing. This thing is really what we want. Yeah. Okay, run that thing. This should be pretty good. We need some type of, coherent editor to look at file data. Cool. Okay, so coherent editor to look at file data. We're getting that to open in a second here. When it does open, here we go. So if you look at sound music, right, there's going to be a lot of stuff in there because there's three different folders. So MP3 music is Warcraft 3. Glue screen and zone music is World of Warcraft. And so I think the fun one would be, I suppose we could just use glue screen music actually. Sure, let's try that. So you go over here to the glue music, where it used to be that one, we put this one and try that. That could be kind of fun. It just, makes it feel more like we're really changing it up. Yeah, it's actually kind of quiet. For me, at least. I don't know, maybe it works for you guys. That seems fun. So we got the different music on there. Maybe we should change the menu logo, too. I wonder where they put the... Let me know where the logo is. Interface. Wait, is that real? Sorry, that's the sound interface folder. That was throwing me off. Okay. The interface folder for World of Warcraft. I was wondering if this had... Okay, so we have like interface icons, right? So that's kind of fun. But I guess what you'd obviously be looking for in here would be not really an icon. It would be like a glue main menu logo. So they have that, but maybe like common Glue's logo. Oh yeah, here you go. Logo left, logo right. glues logo. So how about that? So I guess that's where you have this problem that the logo is a model. UI human. It's just like, oh yeah, you could get like one of these. UI main menu. So this is probably what we're like already loading, right? Is like this thing. So that sort of works, but I guess what it doesn't have figured out is it seems like the logo is only a texture and is not a model, which means that it would be sort of boring and annoying to actually try to set it up, because you'd have to actually probably edit the file path on that or something like that, right? Basically, if you like export this to whatever is that one that's actually getting used, so you'd have to go to your resources folder, and then I think it's like replaceable textures, world edit UI, Warcraft 3 logo exp, or like something like that, right? Which is sort of annoying. Replaceable textures, world edit UI, Warcraft 3 FT logo, not logo exp. So you could try to do that, right? But that's pretty silly and annoying. Sorry, I keep going to the wrong folder here. I mean, I'm basically just procrastinating, having fun with the menu, because that's so much easier than doing stuff with the map. Obviously, doing stuff with the map is still, like I said, it's physically possible, but it's just a little bit more annoying to do. Let's go to this replaceable textures. So we found out it's not -exp. It's supposed to be Warcraft 3 FT logo, which might work, probably won't work. Let's find out. Also, we still want to get rid of the annoying wind noise, you know? Glue screen loop is like glue screen wind. Let's do one of these and try to, I don't know, tone down the glue screen wind maybe. See if that helps. Yeah, how about that? Look at that. Now you got a different logo up here. Different music. Seems like fun. Now, I'm sure somebody will tell me the particles coming through the gateway there. We might be using Warcraft 3 particle render tech. It might not actually be exactly World of Warcraft render technology, but obviously it's as true to form as it can be when parsing the files. Cool. So, what we need basically is we need like Eastern Kingoms as a map we can click on, and that's just not, it's just not what it's doing right now, We could try to make it do that, but that's not at this moment what it was doing. It's also interesting to think that the loading screen, is not like a World of Warcraft loading screen. We might want to play with that. That could be sort of fun. Just get it a little bit more thematic. Let's see what we got. Cool. Here I am in the world. We got our character again. So that's pretty fun. I've got my character. I've got all this stuff working. But yeah, I guess. Oh yeah, you know what else? Actually, so the music's not very loud for me, but I wonder if the music is loud for people watching this. And if it is, that would mean they couldn't hear what I was saying when I was pointing out the logo and that sort of thing. That usually is how my videos go. So what was I trying to say? So if we think about what I was trying to say, I was saying that the menu was now more fun because we changed the logo. But I guess what we didn't really do is we didn't really change the loading screen. So that's another one. I think loading screen is in here. Loading screen. Loading screen. Loading melee background. Loading progress bar. So you could try to get, I don't know, do we have World of Warcraft load bar in here? So interface glues loading bar. Yeah, obviously it's almost nearly the same. They definitely based it on the same exact bar in both games. But then you think about, is the World of Warcraft one a little bit different, maybe? It's possible. It's possible that it is UI glues loading load bar. So maybe that could change, but I don't actually see. I guess World of Warcraft probably uses XML to define its load bar instead of FDF, which, you know, some programmer might tell you is better, and he might be right about that. But it does bring, you know, I guess, bring up the question, sort of like, what is the, yeah, you know, like, let's say you want this to be your background there. Is that something you can do? What is loading old? Why is it empty versus loading? Loading and loading old. I don't know. Loading old doesn't load. So we have textures for the loading bar, but we don't seem to have buttons for the loading bar. Okay, big button glow, big button, edit box. I wonder, yeah, I don't know. I'm not really sure about where we would put buttons. They have like a button highlight. This supposed to be a really small thing, right? Oh yeah, here we go. So this is like your quest giver thing. So that's a distraction. That's not really what I'm looking for. I was looking for like a button. Yeah, like this kind of button, right? This kind of button. And I'm not quite sure. Okay, micro button, panel button. Maybe they don't format it the same as Warcraft 3. Warcraft 3 had some stuff going on with its buttons. It's going to make these buttons difficult. You know, if you wanted to just kind of pop these onto the menu, maybe it wouldn't really fit. That's sort of unfortunate. Whatever. Oh yeah, see, this kind of thing. This is what Warcraft 3 like to do. They like to do this weird, you know, texture with the 8 different sides on it. Autocast button. This is probably too small to see, but you know, it could be fixed. Okay. Glow star, button highlight. Obviously, oh yeah, backpack button. Sure. So we have the buttons in there. We don't seem to have the same kind of glue buttons that I thought we had in the other world, but maybe that's okay. Warcraft 3 stuff. So that's what it is, I guess. Yeah, we're not going to probably fix the loading screen. Having seen that the you know, the concept of the loading bar in the glues folder is just textures and the background is just an image, leaves me to think that there's probably glue XML, probably login, create, realm list. One of these is probably a loading thing. Might even be frame XML. I wonder. Maybe not. But it's probably non-trivial to go and find that. So that's sort of annoying. Yeah, I don't know. I mean, you could put this as the background if you wanted to, but it just looks like it's going to be a waste of time. So let's try to get the actual map file. You know, we're going to have Warcraft 3 load screens and UIs and stuff, but let's try to get the actual map file. So to get the actual map file, how would you do that? Because, you know, like we said previously, we pretty much have to go to whatever that thing is, what, wowdev.wiki or something? That's not quite right, but yeah, wowdev.wiki. And we want to go to WTL files, which specify what map tiles are in a world and have a chunked file structure. So we have to parse this binary. This is kind of painful, right? This would be the only way that I know of that you're going to get this map into Warcraft 3. You have to understand this format in order to get it out, or use someone else's program to do it. I don't really want to do that because then I don't really control it and I can't make it right if it's wrong. So we got to read these, and I think the first thing we want to do, we need a sample file, which we have, and then we want to try to read that file. So let's get the map. So WoW3 The Frozen Throne, I put the map in here, right? In our actual game folder in what, core assets maps, Oh, I put Death Knight starting bundle in here. Oh, sorry. Okay, so somewhere else outside of that, we have what? WoW, files, data. What is textures? Minimap? Oh, it's some kind of textures folder. Okay, and then world maps. So there's world maps and there's world WMO. I don't exactly know what WMO is, but I think it has to do with buildings you can interact with. And War Smash probably doesn't handle these very well. Somebody might have seen there was a video of War Smash WoW emulation where I was using something like the WMO files. It looked like them, and I was inside of a dungeon. But what I actually did was stupider than that. Somebody sent me a Warcraft model of the dungeon. It was like, why don't you run around on this? And I think they're trolling because there's optimizations inside of the WMO files to allow you to interact with them, right? Like your game would lag horribly if you just load one giant model of a giant dungeon and run around on it. Like you actually want it like chunks to be like pieces of, what are you interacting with, and mathematically only process that part. So I had to do a whole bunch of code changes to make individual Warcraft 3 models work that same way. And so you could imagine maybe you could try to like port these WMO files to Warcraft 3 model counterparts, and maybe the War Smash code I wrote would actually be smart enough to then optimize for that in a way that it would not, like actual Warcraft 3 would probably not do, because the components of the actual Warcraft 3 models are usually on a per model, model as a model kind of basis. Maybe. I don't know. I'm going to just start by not doing WMOs because that seems easier than doing WMOs. So I feel like most of what we probably want is this WDT MPQ file. Whatever this thing is, this is probably what we want. So I guess what we want to do, we want to copy this file path, and we want to start off with a file investigation. In order to really understand our file, we need an investigation of what is in this file, because it is not a Warcraft 3 map. I'm not super familiar with exactly what it is, but I know what it's not, and I know that it's not a Warcraft 3 map. So let's go to our parsers folder, and you can see we have W3X, and this is how we parse a Warcraft 3 map. And maybe what we want to put in here is just a new folder for WTL, I guess, whatever that is, WTL. Okay, so the first question is, I don't know why I said TL. Sorry, WDT. Okay, WDT. What's there we go. No, what's the hotkey for this? That one. WDT. WDT. Okay. So the first investigation, I think, tests with WDT. This is our test file. Okay, so I'm actually just making a new computer program inside of the War Smash project so that. Can you guys still hear me? My mic has moved a little bit. I'm making a new. I'm gonna move this mic closer to my mouth just in case that makes it clearer to hear me. So I'm making a new computer program inside the War Smash folder. This computer program, it has all of War Smash linked against it. So we have extra code libraries, other things to use. But for starters, we just want to be like, hello world, and make sure we can run a program that's linked against War Smash. This is important because doing that, it's like, oh, see, there you go, hello world. But not only can I hello world, I can also be like new War 3 map, whatever that thing is. I don't know, just null or something. And okay, so I don't have the inputs to create that, but in premise, whatever that is it's ambiguous constructor. Okay, new folder data source. I don't know, something like that. It was just not. What is it mad about? What's the data source and a map file name? Okay, so I just wanted to prove that I could compile this. You can't make a data source from an empty string. Oh, yeah, okay. So this is my dumb APIs of War Smash. Okay, folder data source descriptor dot create. Okay, sure. Point being, Warcraft 3 map, it's a code file. I can spin it up. I can parse Warcraft 3 maps, whatever. We want to use that same notion to be able to spin up parsing of WDT files so we can put them into the game. Right now this is going to depend on someone telling me what's in those files, because I don't have the time in my life to go and figure it out. So, this is just based on whatever this is, and if it's wrong, we're screwed, and we're just not going to even try. So let's have a look at this. So this is MPHD chunks. What is it? This is some kind of header. Let's see if we can find that header first off. So it has, I guess, flags, something, and unused, MPHD. So yeah, let's see if we can figure this out. 8 32-bit integers, or not. Apparently, a lot of this is pertaining to BFA, which is a distraction, because BFA is so far in the future, I don't think you would ever want to touch it. Okay, if you're gonna play BFA, you're gonna do that on Blizzard's server. Okay, what I'm doing is modding Warcraft 3. We're not doing that. Okay, so all of this is a bunch of crap. Most of these are not good. There's a lot of unknowns. Unknowns are bad. Unknowns mean we don't know stuff. On Warcraft 3, we know everything. Okay, we don't have this problem anymore. Alright, and we know everything because of people like Ghostwolf working for years and years and years, not because anyone gave it to us. Okay, many years, by the way. Alright, affects the rendering of LOD ADT. Textures not, or else textures further than... Okay, I don't care what that is. So most of the stuff, you look at this, you could read through this, and it's just a bunch of distractions. Like, it doesn't matter. What we really want to do is we want to load a geometry. We're going to lag War Smash. This is fine. We're going to load the entire geometry of all the Eastern Kingdoms at one time. It's probably going to break. But you know that's okay. That's okay, right? It was just break it, you know? You read it, you break it, and then if it's broken, you fix it. That seems reasonable. So let's try to see if we can turn the entire map of Eastern Kingdoms into a Warcraft 3 map. I mean, I don't really think it's going to succeed, but let's try it, right? Okay, what does this need? So I think the MPHD chunk is the first thing I'd like to try to read. And the very first question, too, I guess, is these things say that they're inside of an MPQ. So let's copy them. I'm a little bit hesitant to even believe if they're really an MPQ, but let's go to... I'm going to make a folder, Modified Maps. And in this folder, I'm going to put Azeroth. And this is my Modified Azeroth Maps folder. Now, one thing we want to check, if we go to this in the command line terminal, remember earlier I was doing sfmpq-x to extract MPQs? We want to try this. It'll probably explode. I don't even think... Sorry, I think it's not sfmp. It was just smpq. I doubt it'll work. It might even turn into infinite loop and burn up the computer. They might try to do that. Because some of the times these things that have .mpq on the end are just a lie. They're not really an MPQ. Oh, that's interesting. It actually does think that it un-MPQ'd it somehow. Oh, that's weird. Okay, so that's also troubling. But what do we think are in these files? So now we have file 0 and file 1. I don't know. What is this? This is REVM. Okay, so one file is an REVM file. The other file, what does this say at the top? Oh, it's like empty. It's some kind of junk. REVM. I don't actually know what an REVM file is. REVM and IAM. Are these things that we have mapped in here? These don't look like... Oh! NIAM is main backwards. Okay, yeah. It's the Indianness. So MVER is MVER. So this is the fogs. Fogs for a subset of WTDS. They seem to be only present for terrain maps, not WMO maps. They're all empty and not read by the client. They're merged in the branch by accident and are a BFA feature. First files with content are Zandalar and Kulturas. Okay, so that's a bunch of crap. Somehow they have this notion of MVER showing up even before that. You can see why no one does this. Okay, so obviously that's a bunch of crap. Can I do the same thing on the actual WTT file? No, it actually is an MPQ. Look at that. It says MPQ at the front. So it's actually an MPQ, and that means that un-MPQing it is perhaps actually valuable to do that. But I don't know which of these two files is the good one and the bad one. And so we're going to assume that file 0 is the good one, and I'm going to rename it to Azeroth WDT. Okay, so the idea here in my mind is that that is like the un-MPQ'd WTT file, I guess. Cool. So that would be the file that we want to try to read with our computer program, which is probably going to fail. But you can imagine, again, if we look at this file, it starts off... Oh, don't do that. Okay, sorry. We use less to read less of the file at a time. Cool. So it starts off with whatever this mver thing is at the top, which is probably telling us the version number. And I find it sort of unfortunate that this thing doesn't seem to know about that. They seem to be, it's like they wrote this for parsing some really old thing that doesn't match what we're looking at, which is kind of unfortunate, you know? Okay. They're only used for ADT maps. Okay. So, all right. So basically version. So I would imagine this thing seems like something that has some data. MPHD comes after M version. What is MPHD? Do we know what that is? MPHD? No, MPHD chunk here at the top. Okay, so this is map header. So we have version and then we have header. All right. The chunked file structure is, I think, pretty much the same. Well, okay. I would imagine it's extremely similar to MDX. So this points out perhaps we should be using the same kind of parser that we use for MDX. Now the kiddos at Hive Workshop, whatever, they messed up my MDX parser. I had it all really nice for War Smash, and I let them go at it and they messed it up. But we could potentially try to reuse some of that same code. Cool. So if you think about the way that should work, somewhere here this would have load MDX, right? Okay, so this is what we're using, load MDX from a byte buffer. Now if we wanted to have a similar file, WT2 map, we would want to rename this to that. Obviously this is a programming video, so we are going to be programming. WDT map. Okay, so we have to be able to load a WDT map and a map. We are not going to support loading and saving both. I don't feel like doing that. All right, so here we go. WDT map. Yeah, these are dumb constants. They're really stupid. Yeah, and I don't really like the way those constants are expressed, but for now, we'll just let it be that way. So we know that we need mver, right? Okay, so basically I'm going to delete all these other constants because we're not going to use any of them. Or if we are, we're going to reintroduce them. Mver, which is going to tell us the version. I'm not going to leave comments for now. I'm going to have some of that for later. So most of this stuff I don't care about, but it has a load function. What is this? This is so sad. This is no. Okay, MV. Why is this how this works? ER. Okay, mver. Cool. So this load MDX, load WDT. How about that? WDT files start with mver probably. Okay, this function over here, I'm just going to delete the contents of that. Did not see mver. So the idea here is that the MDX files from Warcraft 3 have both a text version and a binary version. I only have the binary version of this map, and I'm not going to read the text version, so we're discarding a bunch of the code here. I also think that for the time being, I'm going to discard the save function, which means discarding anything that has the name save in it. So mostly I'm deleting these things down to where I'm just going to borrow the same skeleton code for parsing things. Now, arguably, maybe it shouldn't have to be like that, but that's probably what I'm going to do. Okay. Most of this stuff, don't need it. Don't need save. Anything that says save, we just nuke it. hopefully we don't need to compute byte length. That's always a really sad thing to do. Let me just return a stupid number on that one. In fact, why don't we just not compute byte length? Okay. Yeah, bind post doesn't exist. Version, name, animations, all this other stuff. This is all, we don't need any of that. Okay. So we delete most of the stuff down to just some sort of notion of parsing, hopefully. Okay. Cool. Notion of parsing. So the first thing that we should read probably is mver. Nice. And we read the tag and we read the size. And then we read the data. Now, I'm going to use load version chunk and all this other stuff. I guess I'm going to delete for now, or maybe just comment it out. Okay. We might want to keep this notion of unknown chunks, though. That's kind of fun. So we'll have unknown chunks and we'll have version. Version, I'm going to start out at 0. Yeah, so I think that this might work. This is kind of fun, right? So if this works, what is this stuff that's failing? Load model chunk. Okay, so obviously we can't do that. Load static objects. Load dynamic objects. I'm going to turn that off for now. Well, bind, pose, and pivot point and just delete. Those don't even apply. Static and dynamic, we might come back to that. We'll just comment it out for now. It's kind of gross to do that, but I'm trying to get this thing working. Load model block on a token stream is gone. Yeah, another MDL token stream gone. These load object things, they might be useful. Just import this stuff. Maybe that'll make it stop complaining. What is this one complaining about? Oh, MDLX chunk is different than MDLX block. Okay, great. Cool. So now we have a file that compiles to the point that we could actually use it. So I can say like, oh, how about new WDT map from a buffer. Now this is where it's a little bit sad that it needs a byte buffer. So let's do new folder data source descriptor. We got to get our Azeroth map out of our Azeroth folder. Okay, great. So this is the War Smash data loading system. Maybe it leaves something to be desired, but is what it is. Cool. So we have this data source, which means that we can say data source dot read Azeroth dot WDT. Cool. Now we have the map. Maybe. Now where does this fail? Okay, so yeah, I guess we just put one of these error checkers on it. What I'm kind of interested in is, can we print out map.version? Will it actually read the version using the version chunketing thing? Hello world, did not see mver. Okay, so that didn't work, mver. So I guess you have this problem that I guess it's interesting to think that when we try to express mver like this, mver, it does appear to be in the format revm, right? Is that how that works? Yeah, okay, so revm. So there's a weirdness going on where these are like reversed. It's sort of the endianness, which is kind of weird. Revm. So mver is revm. Oh, loading unknown chunk. That might be okay. No, it's not okay. All right. So the fundamental chunking concept is not working, but that's not really hugely surprising. Yeah, because this is just reading, it's assuming that every single chunk has a size. They might not. This might be some kind of newer chunked format. Token size and then data of size. So you think that's what we're doing, like read read a tag, integer tag. Oh, so this is probably wrong because this actually should be mvar up here. You'll see why I'm thinking this. Are you guys thinking the same thing? That read tag flips the tag when it reads it, so it ends up being correct. That makes sense. Yeah. So now it's like, okay, we have a bunch of unknown tags, and then we have version 0. So that's sort of interesting to say that that's version 0, because what I see here is mvar, and then I see that it's 4 bytes long, and then I see this, which is telling me, what is this, like octal 22? It's definitely a non-zero version. So I disagree, but the parser probably scrapped the version chunk. So let's go in here to version chunk and see if we actually can load version chunk. Yeah, we're scrapping the version chunk. So we go into debugger, and the debugger lets us look at what we think we're parsing, right? So we're like, okay, so I parsed the tag, unknown chunk.add. Now it is also weird that this doesn't have a break statement on here. It seems a bit wrong. Loading unknown chunk revm. So that's already stupid. Okay. Apparently read tag is not saving us. You know, it's like read int 32. So it's reversing and then it's reversing back or something. It's pretty stupid. All right. So it does seem like mvar is revm. That's stupid. Okay. This is probably easier to express in C++ when they originally wrote it versus the language I'm using here. But you know, it is what it is, right? Okay. Oh, cool. So actually now we did think that we read a version chunk there, if you saw that jump through that. So let's see where we end up. There's clearly a lot of data in this map. Whatever MCNK is, there's a lot of those. MCNK. What is MCNK? MCNK. Okay. MCNK is not even coming up. Oh, maybe this is an ADT file. Maybe I'm wrong to think it was a WDT. Okay, a chunked structure just like WDT. This seems to say it has a lot of MCNK. Map chunk. Oh, map chunk, MCNK. See, this sounds like what we're looking for. Yeah, I don't know why it said WDT. It's probably an ADT. So maybe we should like rename it. I wonder if that makes sense. Rename it to ADT, because I have no idea. I don't know its file extension. All right. They didn't tell me that. This also seems to be stuck in an infinite loop. I wonder if it's stuck in an infinite loop. So first off, we got to put mvar back, and then I just, for my sanity, instead of read tag, we're just going to read a standard int 32 so it doesn't flip it back. But that's fine. That's probably the optimization that people originally building this thing did and why it ends up like that. Also, this should have a break statement just for good measure. I don't know. Let's see where that gets us. Oh, buffer is null. Oh yeah, buffer is null because I changed the name to ADT, because I'm guessing it's an ADT file now because I have no idea. All right, let's try again. MCNK. That's a lot of MCNKs, but it does seem to be, hey, there you go, version 18. That's what you want to see. So then you have to ask yourself, what is 12 in hex printed in decimal? Do you guys know what that is? Well, I'm pretty sure if we, what is it? Echo $16. This is probably not quite correct, but it's something like this. 16 £12 is 18. Look at that. I was right. It's 18. Okay. Sorry, I'm celebrating. I'm typing exit wrong. It is 18. Look at that. So the version number is 18. So we actually did parse the version number. So we've chunked out our version parsing. And now we can look at mphd to get our map header. And this is where we start moving. You know, usually these things, it's the configurational understanding of how to read the thing that can slow you down. Once you get there, you start moving pretty fast. Because now we can just be like, oh, okay, so I can read an mver chunk. Well, how about I read an mphd chunk? I don't even know what that is, but we're about to find out. Okay, so maybe ADT files don't even exist in this old version. I mean, it is kind of like we're just making stuff up, but we'll see what we got. So mphd chunk. This thinks that mphd has like flags and then some other somethings. Something and 6 unused values. What are those 6 unused values? You know, that's pretty stupid. Load header chunk, you know, and it's sort of like load version chunk. You want to have like load header chunk. And then we just want to store off flags, I guess. So that's fun. We'll create a flags variable. Something, header something. We don't know what it is, which is really stupid. Yeah, and then some kind of array. So I think the reader actually probably has read int32 array. Yeah, okay, read int32 array. So after header something, this is where you would want to have, what do they call these things again? Unused. I doubt it, but okay. Unused. All right, unused. And for my purposes, let's call them header unused, because I'm going to forget what they are. Cool. So that means that, you know what else is going on here? Some of these parsers I copied from Ghostwolf, they just use public variables. It lets you pretty easily print them out. It's kind of stupid, but now I can print out header something, and I can print out flags. Flags. Okay. And then you can think about, why don't I print out the unused data? Header unused. Sure. Okay. So read all these map chunks, which is really what we're going to want, is those map chunks, right? Definitely. And then, okay, oh, that's fun. So header unused is an array. So in this stupid programming language here, we actually need to use arrays to string on header unused in order to actually see it. Again, that's sort of unfortunate, but that's fine. Cool. Parts map. What do we got? Header something, header unused. Cool. So the flags are 3090, and then something is 65,692. And then header unused, which seems to be, you know, these numbers. We don't really know what these numbers are, but we read them. Okay, so that's the map header. So then we have the main section. Now, what is main, you might ask? And that was a good question. I have no idea. But let's find out, you know? Okay, M-A-I-N. So if you see main, we will parse it. Case main. Load main chunk. Now, what is the main chunk? I don't know. Let's find out. Okay, load main chunk. The internet will tell us. This is how we parse files. Okay. Main chunk. Main chunk needs to contain 64 by 64 equals 4096 entries of size of SM area info, 8 bytes each. A map tile table. Okay, this is starting to get really interesting, right? We're gonna need this. Like, what is this, right? On Cataclysm 2, I don't care about Cataclysm 2. Okay, SM area info. So we're gonna have to define this. Apparently it is an array of 4096 entries. And you'd think to yourself, why is it exactly that many entries? I don't know. Let's find out. Okay, until the maps are split into ADTs. Oh, well, they aren't. Mine aren't. Okay. If version less than whatever. So we're going to have offset and size. Okay, so we need to define this thing that we're looking at. Also, I totally regret changing this file to be called ADT. I think it's a WDT. Let's change it back. Okay. Cool. So it's a WDT, WDT map, which means our test needs to read the WDT. Cool. So that makes sense, but now that we're reading the main chunk, it does seem like we need a special class for this. So we're going to have something that they call SM area info. Now, I don't know what that is. We're gonna find out, but we'll have some of those. Okay, great. So load main chunk. This thing. This, we have to delete the contents of this, and instead, I guess these are 8-byte things. So this gets kind of to where, you know, we might be able to reuse some of these things from the original file I copied, which in some instances, you know, would load stuff. We have a count of things to read and dynamic objects. And should we make it like one of those, right? Which it almost makes sense, maybe. Maybe. We just reuse this other parsing stuff. What's an example of one of those? Like a camera, you know, a camera does this kind of thing. It's sort of like that, except if somebody calls these MDL functions that are non-binary, we're just going to shut off because that should never happen. Okay, so also writing, we're not going to be writing these. Okay, great. So if I want to define how to read an SM area info, obviously there's some version number until we're split. We're just assuming that we're not. So we are going to first read uint32. Excuse me. We're going to read a uint32 for offset and size. Okay, so this is offset and then size. So that makes sense. Offset and then size. And then some newer version doesn't matter. And then newer version doesn't matter. And then loaded, I don't know what loaded is. And async ID, which is only set during runtime, which is crazy because I don't care about this at runtime. Okay. They do appear to be uint32s. Loaded and async ID. Okay, great. So this seems to be how I read an SM area info. Seems like all of these, you know, we want to do some more of this, some more of that. No? What's the hotkey for this? I don't know. Okay, great. Anyway, so we have all of those. I guess we could get like some get and set functions, you know. Okay, cool. So you can like access that, you can read that. That seems good because hopefully that means this thing could actually just, you know, load n dynamic objects where n is 64 times 64, I guess. I'm hoping it'll be that easy. And then maybe we don't have to actually do that, load n dynamic objects. Oh, there is this descriptor thing, okay, which apparently we can just cheat and say sm area info new reader. The count is 64 times 64, and then this is sm area infos, which would be some kind of like list or something. And maybe the automatically existing magic parse function will just parse it for us. Apparently not, though. Load n dynamic objects. It seems to be that if I go back to this, that it was commented out. Okay, so then you wonder, why did we do that? No idea. It looks like it works now. Okay, great. So, compile error. Can't do that. Oh, it has to be an MDX block and an MDLX chunk. Why does it have to do that? Okay. Has to be a block and a chunk. Sure. What's the point of that? It needs to be able to get its length. Okay, so this would be 4 times 4, I guess. Okay, because we seem to have 4 uint32s. Now, I guess the problem becomes SM area infos. You're going to want like a toString on this that is, you know, generate a function that prints out their contents. Yeah, and that helps us log what we think they are, because that way you can see if they're roughly the same, you know, these infos that we have to print out. Maybe, I don't know. Worth figuring it out, right? Cool, so this will parse again, load all the chunks, and then print out the area infos to hopefully get us some view into that. This just seems like a lot of nothing here. This looks broken. Some of them have data, but a lot of them are empty, which seems like wrong, probably. See how there's like this kind of repeating wrongness? You know, it does make you wonder, what is that? Let's try to see. I'm curious. At the end of parsing this, why does this think this is a compiler? Cool. Yeah, at the end of parsing this, do we find error data or do we find another 4-letter ID after this? I'm curious. This weird 64 times 64 thing. Probably be an unknown. MDNM. That's kind of weird. So it actually was, I mean, maybe that's accurate. Just randomly 64 times 64 of these things. Wait, what is all this unknown chunk? No, that's wrong. What is all that unknown chunk? That's wrong. There shouldn't be that much unknown chunk. So did we not read enough map header? MPHD, and then like one length thing 4 5. Okay. MPHD length, right? Flags header something. Boom boom. 1 2 3 4 5 6 7 8 somethings, and then main. So they're not correct about the length of the header. They're lying to me. And then you think, why are they lying to me? The map header does not match what they say. It seems to have more stuff than what they say. And what do you do with that? Okay, so definitely this thing is not, what I have here is not mapping the size of what they have. You know, they have something, and then I actually have 1 2 3 4 somethings. So even if the first thing is flags, I have like something 1 2 and 3, and then they refer to having 6 empty unused things. I have 8 empty unused things. I don't know why I have that. Okay, header something. Header something 2 and 3, and then the unused. Let's see if that fixes it, so we don't have these unknown chunk errors from a confused parser. Oh yeah, okay, wait, it worked, it worked. Now, this does also make you wonder, what are those numbers? You know, what did you read? So header unused is just a bunch of zeros. Header something is just a bunch of zeros. Oh, and this is because I actually wanted to go down there, probably. So header something. We have these numbers, and it's like, well, what are those numbers? That's a good question. Flags continues to be 3090. The other numbers, I'm not really sure. 488. They're probably something. They probably will later on decode to something meaningful, but right now, they don't mean anything to me. So let's just run with it. I wonder actually if, like, wow. What was that one? The other time I looked up 0.5.3. Somebody. Okay, this guy was like, oh, we made a new emulator. Maybe his emulator. There you go. Barncastle Alpha Wow emulator thing. Common. Like I wonder. So he has like DBC readers, but does he have a map reader? Does this thing even work? World object? Oh wait, yeah, we should just search this repo for MPHD. Oh, that's right, you can't search on GitHub because Microsoft are villains. Okay, alright. They used to be able to search, but then they took it away. Alright, Microsoft. We're just gonna copy the code, whatever this is, copy that. Right, and then we're gonna go to our WoW3 folder. Actually, I don't even want to do that. Let's just go to TMP, the temp drive on my computer, the temporary folder. Is this leaking personal information? Is this a temporary folder? What is all this stuff? I don't know what any of that is, so let's just assume it's not. Okay, temporary folder, Alpha WoW. We'll go to Alpha WoW, git clone this thing. I'm curious if we can find in this guy's thing, MPHD, in any file anywhere. No. Okay. That sucks. All right. So if we can't do that, let's try to see, does he have credits? Does he accredit any other people who do the same thing? Really? No. Okay, somebody wants to emulate it. It's just trolls, probably. Wow, format parser. How about that? MPQ. Okay, well that's some other thing, right? Oh yeah, WDT. Here we go. This guy was doing this. All right. MPHD. What do we got here? What does he think this is? He thinks that build is older than a certain number. Be the doodad names, object names. See, this is he's figuring it out better, probably. Oh, I should just go to WDT. Okay, so what do we think of a WDT? What do we got? MPHD is alpha format 1, else size over 32. MPHD. Oh, so I guess after the alpha there could be more of these, but I don't care because I'm in the alpha. So great. So MPHD, yeah, it's literally this MPHD is what it is, he thinks. So these things that I'm reading, we can start to record what they actually are instead of being broken, which is definitely how you'd want to do this. You want as much information as possible, right? Okay, so we think that the first number is not header something. That's just wrong. It's actually n doodad names. That sounds promising. And then offs doodad names. whatever that is. This will probably come back to get us. And then a bunch of 112. So think about 112, right? So if I get a calculator, accessories calculator, I was reading 8 nothings. My 8 nothings are each 32. No, that still doesn't make sense. 8 nothings, 4 bytes would be 32, but he's got 112. Why does he have 112 of that? What is he skipping? I don't know what that is. So this thing about flags and 2 unknowns. This is for people who don't have what I have. Okay, so that's great. So we actually want to read end doodad names. So it isn't even flags. Flags is just wrong. It isn't flags. It's not flags. It's doodad names, offs doodad names, end map object names, and then what? How are we editing both of these? Let's see. Offs map object names. Cool. And then some header unused that, in my experience, seems to be 8 groups of 4, which would be 32. But he seems to think it's 112, which doesn't really match my math. You know, like, what is 112 divided by 8? What do you think that is? 14? So he seems to think there's like 14 of something. I don't know what that is. For now, I'm going to do this, but this seems to suggest there's maybe a dynamically sized component here that he was seeing a different size than I'm seeing or something. I don't really know. Cool. So yeah, I don't know about that, but what we do know is that that's probably the way to load this, which points out, you know, he's got the exact same thing going on here. So the main, he seems to think the main is a 64 by 64 main. And he seems to think that main is offset size flags and async ID that he throws away. Okay, and flags is, so it's not actually loaded. So that's also wrong, apparently. That in our SM area info, probably offset size loaded shouldn't still be called flags, which then points out this generated code is also wrong. Are we missing the getters? The getters are the most important thing. Get offset, get size, get flags, get async. Okay, cool. And then regenerate this stringify. Okay, cool. So that seems pretty good. Now we have this thing, but yeah, it has ADT and loaded. So I would imagine it's really just basically loaded in this older version is what the flags are going to be. But we're back to, okay, if we can parse all that, then we have to find MODF would be object definitions. So let's take a look at those. MODF, object definitions. What else do we need? Okay, main, MODF, MODF, cool. MODF, which then gives us object definitions, which probably like SM area info, we could define as like a chunk kind of thing. Yeah, what do you call that? You know, so this guy just called it MODF, but obviously if we actually know that MODF is in map object definition, why don't we just call it object definition? Object definition. Cool. So here's my object definition. So this thing, all different parameters, all different, you know, stuff down here. And the different parameters are name ID, name ID, unique ID, which seems to be not signed. Position. Okay, so name ID and unique ID we can create, you know, automatic create fields for. Position, obviously, you want to be a vector, so I guess float array. And it's going to be the same with rotation. And then extents CAA box. What do we suppose that is? That's probably like a, you know, some type of thing. A lot of times the extents would be, is it dynamic, or do you suppose it's just going to be 2 points in 3 dimensions? It might be two 3-dimensional points. Where do you have his AA box in common? Yep. 2 points. Okay. Okay, so object definition is going to have min extent. I think I'm just going to put it here, and max extent. Now I wonder, can we actually just use MDLX extent? Probably not, because it has a bounds radius, unfortunately. Otherwise you could, but we cannot. Okay, cool. So float 32 array, position. I'm gonna just put all these in here: position, rotation, min extent, max extent. Min extent, max extent. Okay, cool. That seems to make sense. So that gives us position, rotation, min extent, max extent. There does seem to be, I assume this is some kind of flags. I always really like flags. Oh, we have the auto correct thing here. We don't want that. Okay, flags. Yep, flags is a member variable. Cool. Now this does create the question, mode of flags. It is an unsigned short, so I'm wrong. It should be uint 16. Apparently they really like that here. Uint 16. All right. So I guess this uses like an int for that. It's a Java problem. Okay. Doodad set. And then name set. And then scale, which is apparently an integer, which I find odd. Okay. Doodad set, name set, scale, which points out we are going to need a parser for whatever, you know, name IDs probably. Cool. So that's all pretty good, but I think we do want to have, okay, byte length. So your byte length on this thing is clearly 4 plus 4 plus 4 times 3 is 12, plus 12 plus 12 plus 12, plus 2 plus 2 plus 2 plus 2. Awesome. So you have byte length. So that should allow us maybe to say, oh yeah, this thing, mdoodad names, off doodad names, and object names, off map object names. Really? Okay. All right. Cool. So I think that seems pretty good, right? Then we have maybe the ability to read these, which would mean that if we hit MODF or whatever in our WT map, we could do another load n dynamic objects. Although we don't really know how many to load, do we? Crap. MODF. Well, just one? Oh, that's kind of stupid. Okay. Object definition. Oh yeah, I should change the name of this to map object definition, I guess. Sounds like. And then this map object definition can read MDX version. Okay, great. And then I guess we could have a list of map object definitions. Object definitions. Cool. So yeah, I think we're back to where we can almost parse stuff. Let's have a look at that. Maybe in a debugger. See what's the first unknown we hit. Probably these other things. Probably M chunk. All right, let's see. Loading unknown chunk. Oh, wrong. So I'm going to say I want to print out what we're reading before we go too much further, you know? Basically, that way, by the time that we would catch this, yeah, okay, so we read mver and we read mphd, and suddenly we have an unknown chunk, which means that our mphd reading is wrong. And that's interesting, right? It points out that my header unused, when I said there's 4 of these and some other thing, maybe it's the wrong length. I don't know. Let's find out. What's the first unknown chunk? Yeah, okay. So you get back here and we say, now I've screwed up my mphd. So we have mphd, we read its size, and then we have 1, 2, 3, 4 meaningful things. And then, in my opinion, 1, 2, 3, 4, 1, 2, 3, 4, 8 zeroed nothings. It sure seems like we would expect, if header unused was 8, that a reading of mphd would be followed up. So here's where we've gone wrong. Maybe. Oh, maybe not. I thought one of these break statements might be missing, but it's not. So we read mphd. It's very interesting that we cannot somehow get past this mphd, which really clearly has 1, then 4 things, then 8 things. Why is this a problem? How is it reading something different than what I'm reading? And that's crazy. mphd gets read, and then it even says the mphd is length 80, right? So like, really I should be doing one of these, find out it's 128 bytes. Right now, 128 bytes over 4 would be 32. Is that true? 128 over, wait a minute, 128 bytes. PhD, 128. So like this is like 2 bytes, right? So this is 4 bytes. So if we think about 4 bytes and we think about how I have what seems to me to be 3 sets of 4 things that are 4 bytes. This would be like 48. There's an extra times 3 in there missing before you'd get anywhere close to 128, and it still is not 128 because it's a power of 2. Okay, so basically my concern is this says it's 128 long, right? And then we have, 4, 8, 16, 16 times 3. I just keep getting 48. It seems like I have 48 bytes, which I guess would mean, what is main a part of map header? Is that the deal? And this is where I went wrong? But that doesn't really explain the problems parsing. Also, main says that its length is, now we have to remember, is this, the endianness is always wrong. So this is what little endian. So if this is little endian, this is a big number. main is big. And that makes sense, because not only is it a big number, but it should also be 2 raised to the 17, which, no, they say it's 4096 of chunks that are 8 in size, or something like that. But that seems wrong too, because that seems like that's half as big as the number it just gave me. So that probably means they're not 8 in size. That probably means they're 16 in size. So I'm just like trying to double check my understandings on everything. So you look at an SM info. Shouldn't this be 16 in size? Yeah. Okay, so that all checks out. So what doesn't check out for me is MPHD. But even if we assume that the size value on MPHD is stupid, it doesn't really explain the MPHD parser going nuts. You know, what is that? We're reading MPHD and we're assuming it has a size. And I'm pretty much discarding the size right now. But don't you think that, like, the size, so for example, like main over here should work just the same if the number of things to read were to be size divided by SM area info, just byte length, which is apparently non-static, which is stupid. But yeah, basically size divided by 16. Okay. I'm definitely overlooking something. Then the question becomes, what am I overlooking, right? So we have these unknown chunks. What are we doing here? Why are we already at an unknown chunk after MPHD? It has to be wrong. It has to be wrong. And we're like, okay, so I read an error chunk, and then what? And I have another error chunk. Okay. And I have, how many of these will I read, you know? Like, apparently a lot of them. Forever. What are we doing? What are we? Something is extremely incorrect. MPHD, load header. So these are all reading real numbers, right? Reading actual numbers. Okay, and then this thing, out length, is 8. Zero tag, zero size. How is that what we see next after reading 8 zeros? We're not looking at the same file or something. Azroth WDT. Do you not see 1, 2, 3, 4, 5, 6, 7, 8? Boom, main. How is this not what we're doing? This is very frustrating now. Something is not what we expect. We're reading the file, we're reading MPHD, we're seeing the same MPHD values that I see, right? I mean, don't you think before all these zeros, these 4 numbers right here, are probably what you'd expect. So, like, let's do an example, right? What do I think they are if I print them out? This same idea that I can convert something in hex should enable me to say, if I'm little endian and I am these numbers, that I should be 0000120C, and I should be able to print that out. And that's wrong, that's 4620. Really? Oh, so is it, maybe I'm wrong about this. Maybe it's 0C12. Yeah, okay, there's 3090. So 0C12, that makes more sense. So then it's like 1009C 65592. You can see that's the same kind of thing there. So these values are getting read, and then after I read 4 of them, I read 8 numbers in a loop. And somehow these 8 numbers don't consume, you know, like 1, 2, 3, 4, 5, 6, 7, 8. They don't consume enough to take us to here. How is this not consuming distance? Okay, so we have this argument reader who has a buffer. Buffer should have a position. Position is 36. Now we step over that. Now position is 68. Now, if position is 68, I should be able to go back here and I should be able to see, you know, this is, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like if this is 4, right? So this is 8, 12, 16. So if I'm at position 16 per row, you guys with me? Per row. Sorry, my microphone fell over. 16, 32, 48, 64, 65, 66, 67, 68. So I should be right here. I should be right here. What are we doing? What are we doing? Okay, then we get to the end of that, and I'm like, I read MPHD, and then I read an integer from a buffer whose position is at position 68. And I read tag, and tag is 0. I am being trolled. What is happening here? We are parsing different data than what is in that file. Why are we doing that? Why does a dump of the file dump something different than what the computer sees? Come on, guys. Who did what to make this happen? Now tag and size are both 0, even though really clearly there's values there that we would have gotten read. You know, we would have thought that the size would be quite large and that the tag would be non-zero. How is that what happens? That does not make sense to me. Is this like the file gets nuked after? Yeah, okay, MPHD, and then a bunch of crap, and then main. How? How many? MPHD, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, you guys are probably laughing in your chairs watching me. Do you see this star? I forgot about this star. They skipped a bunch of data because it was all zeros. That's so stupid. So the guy who added 112 bytes in the parser we were looking at, he was aware of the skip, and I'm doing the skip wrong. That's so dumb. So my unused header data that I had, 8 integers, he didn't have 8 integers. He had 14 integers, right? That was what we saw earlier with, that's so stupid. Okay, see, look at that. Now, actually, maybe he had more than 14 integers. Wait, how many? Okay, so if he does 112 bytes, and I am in 4 byte parts, oh, it's 28 integers. Now, what are those 28 integers? I don't know. That's a good question, but that is also very frustrating. Okay, then we get to main. Yeah, then we go and explode on like modif or something. Okay, cool. So we are actually getting to main, which is then getting us to MDNM. So that's starting to make more sense. MDNM. So MDNM is like doodad files, apparently. MONM and MWMO are apparently world model files. So that's kind of cool. So we would want to start reading those. Apparently HDR is tiles. Yeah, because we got to start reading this stuff. In order to make this work, we have to read these. So that's cool. All right, so let's get some more of these. So MDNM, MDNM, and MONM. Okay, MDNM, DNM, and MONM. Okay, great. And then MHDR. MHDR. Okay. And apparently SYN and TEX, whatever those are, we'll probably get to that later. I wonder if they have that up here. MCIN, MTEX. I don't see it. MTEX. Oh, look, these guys are like, this is Legion Plus. Maybe. Or it's extremely old. You guys have like MCNK. I don't know. Oh, MCIN being gone. Okay, MCIN. Pointers to mchunk and their sizes. So MCIN is something old. Okay. This seems to be explaining what we want here, right? Okay, MSyn, MTex. Textures used for the terrain in the map file, and it has the file names. Okay, so MHDR, we're gonna want MCIN, MTex, MCIN. Okay, MCIN, MTex, MTEX, and what? And motif, MDDF though. DDF, I don't know what that is. Okay, motif, MDDF, DDF. Cool. So we have some more of these. We can start trying to figure out how to parse them. Some of them seem to be in this thing, but not all of them. So WMO or MONM, which it seems like we have ONM, is some kind of reference to WMO files. That makes sense. I don't know how we're going to do that on War Smash, but we can try. WMO. So world model file names is read string size split on 0. World model file names. Really? So this is... Okay, all right. So it's like probably, yeah, okay, all right. So basically just a world model file names. Basically a list of all the world model file names. This is actually quite easy to parse then. Okay, and basically reader.read string. Do they even have that? We don't even have that, do we? Oh, that's stupid. Okay, we have some kind of parse utils, read string. You would think it would work, but it doesn't, because this probably is not what we want. Yeah, this is a string of a defined size. Okay, so basically, size remaining equals size. There. We could make this a function later, but for now, it's just, you know, while size remaining greater than 0. String builder SB is new string builder, and then let's see, byte x while x equals reader.read int 8 not equals 0 sb.append char x. This does not work for multicultural languages, but I'm not going to do that right now. Okay, so we read the bytes until we are done, and then map names, world model file names, add sb to string. Let's see if that works. You know, if we can actually at the end of it breakpoint, we might be able to see the list of file names, which would be kind of fun. It's like that's where you're actually reading something that makes any sense. You know what I mean? MDNM? No. Oh, but that won't happen because we didn't size remaining. Size remaining minus minus. Basically, each time we read something. Otherwise, it wouldn't make any sense. Cool. This, world model file names. Look at that. Guard Tower, Stranglethorn, Collidable Doodads, Stranglethorn, Doodads, Snowy Dwarven Hovel. Boom, boom. See, it's starting to make sense. First, it's the text, and then it's the world. Yes. All right. All right, great. So that's good. That's a good step. We have to get the model object file names for this to work. Okay, doodad file names. Yeah, I don't know, doodad, MDNM. That's literally the exact same. Okay, so we can just read this code. We could probably make a function out of this. Read strings. Okay, now the problem, yeah, terminate. I don't care about that. Okay. The problem is that the world file names read and read strings should be a variable. So we can, oh, sorry. I was trying to use hotkeys and I hit the wrong one there. Yeah, basically, we want to get the world file names as a variable that we're reading into, because that way this can be output. And that way read strings can read into world model file names. And then you can have, you know, that in a sort of clean way. You can do the same thing for MDNM, unlike the O and M. And this would be the doodad model file names, I guess. Doodad model file names. Awesome, doodad model file names. And then, I don't know, I guess HDR is the something about tiles. So tiles.add read tile. So read tile, what does read tile actually do? Similar to SM area info, I think we're going to need a tile class. You know, some whatever that is, tile. In fact, yeah, maybe we'll just literally copy it. Copy one of these things and call it tile. Because we're going to read one of those. And what does that look like? This guy thinks that tile is reset, offset, calculate total ADT size. This is some kind of hacks. I don't like this very much. Read tile looks kind of gross. Let's see if these guys understand what to do with it. So we're looking for something called MHDR. Look at this crazy crap. All maps are divided into 64 by 64 blocks for a total of 496, some of which may be unused. Each block are divided into 16 by 16 chunks, not to be confused with, for example, the file chunks, such as the MHDR chunk. Completely different thing. Always said blocks to be unused. Each block will always be of size. Use all of its 16 by 16 chunks. Each block is 533.3 repeating yards in width and height. If a block is unused, it won't have an ADT file. File will be world maps. Map name, block X, block Y, ADT. What? Okay, we don't have ADT files, so we don't think we do that. But we do have MHDR chunks, so let's see what those are. Okay. Offsets relative to data in the file for specific chunks. Takes us for parsing ADT. Okay. SM map header. Okay. I'll get back. I'm gonna take a video pause here and we'll come back. Okay, so we're trying to get ADTL files. Sorry, not ADTL files. ADT files, which are WDT files or something like that. So in order to do that, we have to get MHDR chunks, whatever those are, and that means that MHDR chunks need to get parsed. So they have this stuff in them, whatever that is, some kind of pointers. I don't actually know if this is even what we're looking at. So you look at this guy. This guy's got an older parser, maybe. He might be, well, I don't know, maybe he's not an older parser, but I thought it might have been, you know? So I need to go back and look at the data, but he seems to think that reading a tile depends upon the offset size into a substream and read ADT of the substream. Which is kind of interesting, right? So he reads ADT of that, and then like substreams, all these different kinds of things, you know, whatever's in an ADT. It's very similar parsing over here, but not entirely the same. Yeah, so this is all pretty interesting. You can see why no one does it. I'm trying to figure out then, do we know, we have our concept of tile. No, we don't have our concept of tile. I guess tile is apparently really bad. I don't like tile anymore. Because read tile, when we get to an HDR, do we even have HDRs? Becomes the question, right? Yes, so we're getting to an HDR. Also apparently didn't know how we load MDNM. Didn't we do something with MDNM? What's MDNM? MDNM. Oh, we know what to do with those now, right? So if I actually run this and just breakpoint on unknown chunk, what's the first unknown chunk? Assuming that we can't parse HDR. Maybe that's the way to do it. You know, it is good to sort of, if we over focus on the data, in our particular case, that's fine, because we want to over focus on the data. The data is, we're more interested in the data than the parser. Unknown chunk. It is MHDR. It's the next thing we're actually encountering that we want to parse. So that is good that we want to do that. But this guy's read tile wants to parse these ADT things, which just seems pretty painful. Total ADT size. Because he's doing this weird thing where he's moving the stream back 8 chunks, which I don't like that. I do not like that. I don't think you want to do that. If possible, that is best avoided. So for example, when I'm parsing MHDR, he's thinking that he will actually like reader dot move the offset and like move backwards in the reader, and that's just like, what is that? You know, I think he's probably doing that so that he can read ADT files that are external files or embedded in the same binary. And there's only one of those that's happening here. Like, I don't need optionality, right? What is get ADT size? Area info get length. How much of get ADT size depends on the stream? If you're looking at the offset in the stream, then what? Literally, he's looking at the position in the stream, and he's doing a for loop, and he's saying if anywhere in the for loop, what a weird thing. Anywhere in the for loop has surpassed the offset in the stream. Then we return the offset who surpassed the stream minus the stream. That seems like, does this make sense to anybody else? If you're watching this video, which will probably happen long after I record it because of the time involved, yeah, leave in the comments what the point of this block is. I don't feel like reading it. Okay, so in premise, the ADT size seems to be this weird notion derived from the stream position that is what we're going to tell the ADT parser is how much it has to read from in its sort of substream. I mean, you can sort of picture how that almost makes sense, especially stream length minus offset is saying like the remaining segment of data. What doesn't really make sense to me is this notion that we're going to do a two-dimensional for loop through the area info, which I guess, again, is okay, it's the stuff from the main. So we do actually have that. But if you do a two-dimensional for loop through that and you look at the offsets in all of those and say if any of those offsets is starting after the starting of this parsing ADT thing, then the amount past the starting of the parsing ADT thing is the amount that you tell the ADT that it can read. So I guess this is basically selecting for like, if after the ADT there's more data, then you need to incorporate that limitation to the length of the ADT block. It just seems so stupid. I don't know. It doesn't seem like you should have to do a double for loop for this. I mean, you could obviously track the minimum as you were parsing these, and then you skip the double loop. Maybe it doesn't matter. I guess you don't really care about performance. However long it takes to read these doesn't matter. People just care whether you can read them or not. So that makes sense. Okay. All right. That just okay. But all we really want to do is read an MHDR file or MHDR key, right? That's really what I want to do, is read an MHDR key. So in order to read the MHDR key, I mean, obviously this is going to see the same key because we walk it backwards, which means map header equals read struct MHDR. So what he's doing essentially is he's reading this MHDR and then he's jumping off to, from there, parse it as though it was an ADT file inside of that file in this like really weird way, because he wanted to be future-proof against other versions of World of Warcraft. I don't care about future-proof. No, I just want to read the data. So let's just do that. So that means I'm just going to do this map header concept, pretty much. MHDR. This is what I really wanted. Okay, we'll just read one of these. Just read one of these, right? Okay, so yeah, okay, we just read that. Right. So we'll try to keep it simple. See if maybe this matches the other thing. What do we even call this thing? I don't even know. This is the other thing. I call the other thing the header. So what is this? This is a tile. This is a tile header, I guess. What a junk. Okay. Reader.read tile header. Or sorry, it's actually just read load tile header. Something like that. We'll see where this goes. Okay. Load tile header. Oh, and we actually probably want to pass the size in there too. That'll quickly become relevant. I don't know. Maybe. Okay, so load tile header. So this tile header concept definitely seems to be that on some other planet this was a good idea. And what do we do with that? So probably MHDR, the tile header, probably it has these things. Now this seems to say they think that it's bigger than that, but they're living in Legion land, so they're probably wrong. Offsets, yeah, size, offset, like this could be the same thing. It's a bit hard to tell. What a crazy bunch of crap. Okay. I'm sure it all has a purpose. It just doesn't really make sense when you've not dealt with it before, right? Okay, so read uint 32. Okay, so this is going to be yeah, I don't know. Okay, tile header. There's a new tile header dot read reader size. Okay, whatever this is, we're trying to abstract it a little bit, maybe, so that way this will be in a class, you know, if we can. Reader.read int 32. Okay, offs info. Offs text. Size text. This is so much more complicated than Warcraft 3 maps. I'm just saying there's a reason to not do this. There is a reason to not do this. Size do. Okay, offs mob. Wait, mob? What is the mob? There's no mobs. Mobs are on the server. Whatever. Okay, offs mob. Size mob. Okay, text do mob. All right. Okay. Create field. This is such a spaghetti. Okay. All right. I think obviously the point of this would be an attempt to construct a system of mini-maps combined together that you can navigate between them, which is actually terrible for my use case because I don't want to rewrite the game. Okay, so I want to just use, I mean, obviously we are, I guess, rewriting Warcraft 3 ism, but it would be nice to make War Smash do the War Smash without this. That's what I mean. Maybe I do want to rewrite the game. Who knows? Yeah, okay. What is this? Read-only byte pad. It's a byte array, but we don't know. Okay, its size is 36. Okay. And you know it's not really padding, you know that we just don't know what it is. That's usually how that goes. Okay, read array, int8 array, pad. Okay. Cool. So then we're going to want a list of tile headers, probably. Tile headers. But this does leave me wondering. Load tile header. Add tile header. You could imagine reader.position start. Okay, and then if start plus size not equal reader.position Yeah. This. Basically, we explode if it's the wrong length, which it probably is. You know, what else is in there? I don't know. Let's try that. Oh, we've got past the HDR. Okay. So, by some mysterious stroke of luck, the HDR was the exact length that we thought it would be. Well, that's cool. Okay. What do we read after the HDR? MSyn. Okay, so MSyn. Now again, what is MSyn? These people sometimes explain stuff even if they don't know really what it is. So their concept of MHDR is much bigger, crazy large stuff. It seems to be, you know, we have offsets for textures, doodads, and whatever else, but they seem to have more going on than that. I guess we should keep those comments from MHDR. So this guy was commenting that the info is MSyn, the textures are MTex, the doodads are DDF, and the object is MODF. Okay, so this is like good to know, I guess. But after reading MHDR, we have to deal with MSyn, and this is the MSyn right here. So MSyn, what is this? MSyn is it's some kind of string typed thing. How does this parse it? So see MSyn. It is another array of 16 by 16 of MSyns. Okay, so similar to this guy who always reads a dynamic set of objects, we got to do that with MSyn. Case MSyn, n dynamic objects, which is chunk infos or something. So, okay, so this is probably, I think that this is not correct. And so what I think I'm getting out of this is that the ADT things are probably subcomponents. And we're going to be reading these chunk infos many times. You know, we're going to want to read like a lot of chunk infos. And those chunk infos are probably supposed to be grouped inside of the current tile header. I wouldn't be surprised at all. Because what this ultimately seems like it probably is a description of a structure that's used dynamically or something. We'll have to figure that out. Okay, chunk infos, 16 times 16 over here. Chunk info, new, I'd imagine. Okay. Oh, CIN is chunk info. Okay, that's why. CIN, chunk info. All right. So similar to SM area info, we want to have chunk info, which is different than SM area info. It's not that at all. Okay. So then you get back to where they use these terrible variable names because they don't know what's going on. You know, it's not because it actually should be. So like this thing. Okay, flags and some sort of padding thing. It's again, so chunk info might actually be identical almost to SM area info for now, but similar to SM area infos. So I guess this gets to where, should I put it in the most recent tile header? Basically that the tile header needs to have chunk infos. I'm probably misunderstanding this, but let's try it. So when we're reading an MSyn, let's apply that MSyn to this .tile headers .get last headers .size -1 to that one's chunk infos. Why is this complaining? Okay, so I should change chunk info to say chunk info, but yeah, what's the problem here? So it's a descriptor for a thing, reader, and count. What is the problem? Oh, okay. Tile headers chunk infos need to be chunk infos. That was a really unhelpful error message. Okay. Yeah. Okay, great. I think that makes sense. Okay, great. Sure. All right, msyn. What's next after msyn? mtex and mddf. Okay. I already look at ddf. Nope. Okay. msyn. Oh, we did msyn. mtex. Okay. So this guy, when he sees mtex, what does he do? He just reads a bunch of strings. Texture file names. Okay. So similar to these things, I think the tile header should have texture file names. Okay. And text. Get last tile header. Yeah, I'm just going to make this a function. Okay. So mtext is going to read strings. Reader size. Texture file names on the most recent tile header again. Cool. So those are the strings of that ODF or DDF. Oh, DDF, map model definitions. Model definitions are size 24. And they are something fun. Okay, so model definitions. So we noticed load n dynamic objects. But what about load dynamic objects? Now, load dynamic objects takes a size instead of an n. So the size can be, maybe that's what we do here. Because if you look at, yeah, it's an array of things of a given size divided by 24, which should solve itself if I just go and make an mddf file class. Cool. Which, do we know what these are? DDFs? What somebody else told us what DDF was and I forgot. DDF. Tell me what it is. Placement information for doodads. Okay, so this is a doodad object definition. This would be doodad definition. DDF. Okay, doodad definition. Awesome. Doodad definitions. Okay, doodad definitions, DDF. Where'd that go? This guy. We like this guy. Okay, he seems to be smart. Name, unique ID. Okay, so that's the same. Name, unique ID, position, rotation, and then it just has scale and flags in a different order. Okay. Scale and flags. That simple? Position, rotation, scale, and flags? Cool. All right. And it has biodome or shrubbery. I don't actually know what biodome is, but shrubbery could be pretty straightforward. Okay, and now we have to change the size of this because we deleted 2 of these and we deleted 2 of these. Okay, so map object definition. Okay, all right, they got me. They got me with the stupid. All right, I edited the wrong one. There we go. All right, doodad definition. Cool. Okay, so what this means, and again, I don't know, I guess this goes in the chunk or something. I might be wrong to put it in the chunk, but let's try. So if I go back to WTT map, load dynamic objects. Yeah. Case mddf. We're just going to load dynamic objects. This same idea, but there's this weird idea that it's inside of the chunk thingamabling. So let's put last tile header again, which is probably wrong, but we'll put doodads or something. And over here we can say doodad definition new, which does mean this guy needs a list of doodad definitions. something like that, like in like that chunk or something, probably. Cool. So that's good. And what else? DDF. I don't know. Oh, CNK. We're definitely going to have to get to CNK. Let's see what happens if I try to read this. When do we break? We break after ODF. That's actually weird that we break after ODF. I'm a little bit surprised. MODF. Okay, so MODF over here apparently should be a bit more like DDF. Perhaps a lot more like DDF. Yeah, maybe we prematurely did that one. Maybe MODF should be like DDF, except like doodads, there should be map object definitions. Maybe that fixes MODF. Something like that. Oh, now we're flummoxed on CNK. All right. So let's go back to debug. See what we can find. Unknown chunk. CNK. Awesome. So CNK is next up. CNK I think is pretty big. Okay, CNK. Oh, CNK is so big. What is a CNK? Oh gosh. Okay. Right. CNK. So similar to how there's chunk info, there needs to just be a chunk. Now a chunk is totally its own crazy thing over here. Yeah, all these getters and setters are going to be totally different. The notion of a chunk. What is this? Okay, chunk. Chunk. Get out of here. Chunk. Okay, chunk. Right. So fundamentally, what do we got here? Reader.read chunk flags. What size is chunk flags? UN32. Okay. Chunk flags. Or maybe just flags? It's just flags. The flags of a chunk. Okay, great. So we're off to a great start. Index X, index Y. All right. What a bunch of crap. Index X, index Y. Now you'll notice here in the parser that he actually reads radius, which is only in the alpha apparently, something they deleted later. So you could imagine this is like if version equals, I guess 18, I don't know, whatever that was. Layers. I'm gonna say or true, and I'm just gonna put alpha in a comment. Someday if somebody sees that, they'll know to fix it. Okay, reader.read int 32. Okay, and layers. Variable to field. Okay. And doodad refs. Cool. Offs height, UN32. Offs normal, offs layer, offs refs, offs alpha. What a bunch of junk. Ba 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 ba. What a bunch of junk. Okay, offs alpha. Will this become a Warcraft 3 map? Probably not. Size alpha. Off shadow, size shadow. Oh, they got the shadow in here too. That's fun. All right. Off shadow, size shadow. So actually, one of the places where I went wrong here is the size. This one appears to be an int 32, and everything else is uint 32, right? So that's, I don't know what's up with that, but let's do it. All right. Area ID. Area ID and map object refs. You know, what is that? No idea. And map object refs. Actually, we probably know what that is. That would, you know, they're telling us it's the number of references. Holes. Okay. Read int. Read uint 16. Holes. Unknown 12. That's some junk if ever there was one. It's the sign of someone who doesn't really care. Unknown 12. Pred text, a structure array of U short of size 8. So I guess we can have like you know, reader dot read uint 16 array, and I could do that. Read bytes. Read bytes here actually tries to turn into a string, which isn't really what we want. We probably want uint 8 array. Maybe read int 8 array. No effect doodad. Okay. Okay, number of sound emitters. Read uint 32. Offset sound emitters. Local variable to field. No sound emitters. Somehow think is not unsigned. Why? Don't know. Liquid, uint 32, okay. Off liquid. Size liquid. And then we have 20 bytes of garbage for some reason. Then we have this crazy crap. Relative start and relative end. So that points out actually that at the start of this chunk there was more I was supposed to do. Okay. Reader.position plus size. Can we not also pass size into this thing? That's sad that we don't also have its size. We need to know its size. Okay, so it doesn't implement these other things anymore. It's going to have its own reading function, and its function is going to tell it the size. Because otherwise, how would you do this? All right. And this would be right here, end pos. Okay. Relative start. Reader dot position. Relative end equals... Isn't this a bit pointless? So then end pos would actually just be relative start plus relative end. That doesn't make any sense either. Relative start is the stream position. Relative end is the end position minus the start. What a bunch of crap. So alpha builds offsets are exclusive of header data. So that means that down here, we just put it down here. Relative start is the position, and relative end is end pos, position plus size, minus relative start. I think that this naming is not smart. The start of the relative data and then the end, like they're not in the same coordinate space, right? It's why, you know? But anyway, okay. So then we have this thing, which seems to be reading the chunk contents, right? It's like read chunk contents, which apparently needs to know reader, relative start, relative end. Read chunk contents. Great. So this reads chunk contents, but there were a couple other things I missed in there too, right? So size liquid got set to null, seemingly suggesting that he doesn't use it or something. And then you think, why is this nullable? But again, if true, size liquid equals 0. Alpha. I'm just going to put, you know, I mean, I guess, okay, sure, we'll do it his way. We'll do it his way then. He seems to know what he's doing. Size liquid equals null. Okay, so when I read the chunk contents, and I really, yeah, let's read the chunk contents. Has liquid, flags, and has liquid. So we want to have this has liquid flag. Maybe, yeah, okay, we can have, I guess, what? Static final class flags. Sure, and this will have public static int is river equals 4. Okay, so we have river, ocean, magma, and slime. Okay, so river is 4, ocean is 8, magma is 16, and slime is 32. And then has liquid is river, or is ocean, or is magma, or is slime. Awesome. So that allows us to start off the function for reading chunk contents by saying Boolean has liquids equals flags and flags has liquid. No, flags dot has liquid not equal 0. And that will tell us if there are any liquids in the thing. And Boolean is alpha equals true. Okay, so that's actually what I should do up here as well, I guess, is alpha. It should be up here, is alpha equals true. And then that way these things are all a little bit more sensible. Okay, is alpha. So there's some stupidity here, but get offsets, relative end is alpha. So this is like constructed in a way to be hard to read, but I'd imagine get offsets relative to relative end is probably really a fairly straightforward concept. So how does that work? So we know the relative end, and he's allocating a list of pairs of offset and token. Why does it have to be that way? Do we have a pair type? Not particularly. Okay, so in order to do what he's doing, we want another class, offset. It's just basically long offset, and we're going to use war3 ID for the token because that's my way of doing these kind of identifiers. Great. So these offsets, you know, you could obviously generate getters and setters and stuff off of that, but why does that never want to generate everything? Okay, great. So sure. So what he's doing is he has a get offsets function, relative end is alpha. And the way that this thing works, to get all of the offsets, first, okay, int offset equals is alpha, okay, not is alpha, then 8, else 0, okay, fine. Offsets, plural, is a list of offsets that are by default created. Okay, so first off, we want a list of offsets. That's pretty straightforward. Very straightforward. Okay, all right, offsets, add what? More of these. I'm going to create offset. Okay. So this is offset height minus the starting offset, and war3 ID from string mcvt. Okay. So we're going to put a bunch of preset ones of these. So offset normal minus offset, and that is mcnr. Okay. Offset layer. MCLY, and then offset refs, MCRF, and then we have some others. Size alpha greater than 0, then we get offsets, offset alpha minus offset, this is an mcal. Okay, now we're going to have some more branches like this. Size shadow, then ovs shadow, mcsh. Okay, sound emitters. I'm probably not going to play the sound emitters in War Smash. I mean, you could imagine you could if you wanted to, but I just doubt it. And sound emitters greater than 0. Then off sound emitters. Okay, MCSE. What else? We already checked has liquid. Why do we have to check has liquid again? Okay, fine. If has liquid, this shedaggles right here. Has liquid or size liquid greater than 8. Now, because of this Java crashing, I'm going to say size liquid not equal null and size liquid. I don't want it to crash. Okay. Then we go to offs liquid and we say MCLQ. Okay. Then he removes all wherein the offset is greater than the relative end. That seems wrong. That seems like you shouldn't have to do that. And he sorts them. That you probably do have to do. I'd like to believe you don't have to remove the ones who surpass the relative end. This is like saying that some of the files are like corrupted, and it's like, why are some of the files corrupted? Okay, offsets.sort. This I can get behind. and we are sorting them on, okay, my little suggester bot is being dumb. Okay, new comparator. Turns out typing it is faster than the suggester bot. Okay, import comparator, add the function. Okay, return offset. What is it? O1.offset. Is this long dot compare O1 dot offset O2 dot offset. Okay, same idea. Same idea. All right. Offsets sorted. Return offsets. Great. So read chunk contents. What's the first thing we do? We get the offsets. For offset pair in get offsets. Relative end is alpha. Great. Now we have this pair. So offset pair dot token is the token. Great. Offset pair dot offset is the offset. Cool. Now he writes to the position. Stream position equals relative. This is sad. This is, I don't know about this. This seems bad. This seems bad. We're going to try it though. I think the reader can actually do this. Reader.position. Oh yeah, okay. Relative start plus offset. Okay. Use chunk header when. Oh, okay. This has to be cast to an integer in Java or something. Stupid. Okay. Use chunk headers when possible. Okay. How do we want to do that? So if not is alpha or token dot equals. Now token dot equals. We do have dot equals on these. So I guess one thing we might want to do is try to have a constant. And I had a note about this before because it seemed very difficult to have a constant. So like if I want mcrf as a constant, extract constant mcrf. Can I do that? I can totally do that. Now wait a minute. Okay. mcly. Well then why don't we just do that? All right. mcrf or token equals mcly. Okay, so if any of that, read IFF chunk. Are you kidding me? What is this? He made his own binary reader and it has a chunk function. What is the point of this? Okay, well, he's going to reference one of these. MCLQ. Yeah, okay. So, use chunk headers when possible. Right. What is the point of that? So he gets the token and then he's looking at like is liquid. If it's liquids, he just skips it. This seems nuts. Okay. Somehow I doubt this is how the code in the original game actually worked. I think that this is probably much crazier and harder to read than any code in the original game probably would have been. But I don't know, because no one tells me. Alright, well thanks to this guy. This guy was being nice. Barn Castle is a nice guy. Alright, so chunk headers. I don't like read IFF chunk. It's an annoying thing. What does that do? You know? And they'll say, well, you can't search for this symbol unless you log in as Microsoft. Log into Microsoft. Like, okay, Microsoft. Read IFF chunk. We have to log in. We have to know who's reading this code. It's an open source piece of code. And that means we have to know who's reading it. That makes sense. That makes sense. Okay. So if it is not alpha, well, I don't care about if it's not alpha, but what about if it's MCRF or MCLY? So if it's MCRF or MCLY, he reads the token, read IFF chunk. It just seems like that would mess up everything. Like if it's MCRF or MCLY, then he reads the token again. Why does he do that? Because then his binary reader would be in the wrong place. This does not make sense. What is the thought process here? Welcome to the world of Blizzard. What are we actually doing here? And why are we doing it? Well, okay, we can try to figure out what read IFF chunk does. Presumably he has a file reader. Okay, maybe this is where you just, you know, Microsoft wants us to log in to do a search, so we have to defeat them. That's what we're doing, is defeating Microsoft, which means we go to the temp directory and we make a folder called Wow Microsoft. And we go into Wow Microsoft and we clone the folder. Okay, great. And then we look for, inside of that folder, we want to try to do a search for read IFF chunk. Here you go, this extensions file, this is going to be it. Sorry, we didn't select everything correctly. That one. Read IFF chunk. Okay, do you see what this does? Read IFF chunk. We read the token, and then we return the token and the int32. So, that makes more sense, kind of, but not really. Read IFF chunk literally just reads a 4-character token and an integer size. Okay. So, why did that need a special function? We can just say reader read int32, read uint32, something like that, right? Read int32. Okay, so this would be the assignment to the token, and then note, what is this? Code is copied from Barncastle on GitHub, and he says, welcome to the world of Blizzard. Okay, great. So, basically, reader.read int32 size, and then we're pretty much saying if size less than or equal to 0 and not capitalized token, which means offset pair dot token dot equals MCLQ. So not that and has liquids. Okay, so if its size is less than 0 and this other weird thing, then we skip parsing that thing. Something. Okay. All right. All right. All right. Then we switch on the token, which we can only do if we have the other stupid format tokens because Java, apparently. So we want to do this. We want to switch on the tokens, but our switch on token function is bad. So how do we want to handle that? I do sort of like having these constants, you know, MCVT, MCNR, MCNR, MCal. These ought to be constants. MCal, MCSH, MCSE. Cool, but it does become a problem, you know, to basically say switch case on something that isn't really good for switch case. I guess, you know, if we copy one of these, you could imagine like this, you know, MCSE. And do one of those as like an integer. Obviously, in a perfect world, we would probably just computer generate all these. I think that's how I got the ones in the MDX world. They're probably computer generated. There's probably not a human doing this. But, yeah, I don't know. Let's see. Oh. MCLY, MCRF. It's just, yeah, it's computer generate. ChatGPT. This is the future, right? This is what they say. Correct the following constants integer values. Okay, thanks ChatGPT. How about that? Are you serious? MCSA. Oh, okay. Correct them each place character in each. Yep. MCSE. Did you see that? They were all MCSE. Now they're corrected. Is that even? Did I get all of them? Yeah. MCSE, MCSH, MCL, MCNR, MCVT, MCLQ. No, wait. Do we have CVT, CNR, TCLQ, CLY, CRF? Yeah, how about that? Okay, sure. You know, it sent a bunch of verbiage that doesn't make any sense, but its verbiage doesn't matter because it knew how to fix what I was asking for. Saves me some typing time. Okay, great. That's what AI is really for. It's the dumb stuff. All right. Cool. So now I have I whatever, which means I can switch case on them, right? And that's pretty good because then we can say switch token.getValue. And I can say like case I am CVT and, you know, case I am CNR. I guess Java has switch on strings too now, but I don't know. Where's the fun in that? All right. MCVT. Actually, I wonder if that's true. You could just switch on a string, maybe. Yeah, I think they added that. But someday, some goober is gonna port this to Android, and he's gonna be really mad if we switch on a string, and then he finds out that he's got the wrong version of Java, and he can't do that. And that's what big companies are for. Okay, let's see. Read VTNR. I don't even know what that is. Why is it VTNR? Why did he do that? Okay. So he's got some weird stuff going on here. Yeah, we need this function, read VTNR. Okay, I'm just pretty much using his code verbatim at this point. We'll see where we get with it, right? So, read VTNR. Yeah, we have to figure out, all right, binary reader, Boolean is alpha. if is alpha, else. We don't care about non-alpha. Legal state exception. Okay, if it is the alpha, then whatever this is, this syntax works over here as well, right? Okay, new int. Why though? You know, that does make you wonder why though. Non-uniform array. 17. What is this? Why though? So 17 numeric values. Half of them 9s and half of them 8s. And the middle value is a 9. Why though? All right, so 999, 999, 99, 888. Okay, like what are we doing? You know, this is the good question. Getting Gordo6908 to the Eastern Kingoms. It turns out the Eastern Kingoms was made up. It was never real to begin with, and you probably shouldn't be trying to get there, because if you wanted to do that, you should go call up Ian Hez or Costas and send him $15, and that is a good way to get there. What is this? Calls. I don't think I have the same non-uniform array type, but what is it? What is non-uniform array? Do we have what common non-uniform array? Did you put that in here? Oh yeah, you did. Okay. I like when you can guess where things are in the code. Okay, row count, column count. Oh, okay. So it's a bunch of columns. This is extremely inefficient programming, by the way. Okay, so he's got an array of column counts. That's so stupid. Okay. So his column counts. How about no? That's all I'm going to say. How about no? Right? How about we don't? How about instead of this, let's make a thing that does the same behavior but better. Right, so he has column count length. He has a row count. And he reads this non-uniform array. A non-uniform array of what exactly? Floats or vectors. Okay. So if it's an array of floats, like VTNR float, right? Okay. What this really should do, VTNR float, we don't really want to see that. What we want to see is apparently, if I'm thinking of this correctly, and this is extremely weird. He figures out the column count, and then he reads that many of the records. So he has 17 rows, and some of them are length 9, and some of them are length 8. It's just, why did he have to do it like that? You know, why did he have to do it like that? That's what I'm thinking. Like, what a thing, you know? 2D array of things, right? And what we really want to do is this every time, you know, this 3, 4, 5, 6. He has 17. All right, so he had 9 9s. So now I have 9 9s, and he had 8 8s. And together it made 17. And you would wonder, why? Why do we have that? Great question. We're going to figure that out. But first, we're going to have 9 9s and 8 8s. And so this is the data which fundamentally exists. And I think it makes sense.
then that for float array row in data, we're going to reader.read float array row. And this is how I would do it, ish. I guess I could see why someone would tell themselves this was not readable code. I could see why. But then I don't have to introduce a new function. And this way I can have read vtnr float, but he also has read vtnr, a 3-byte thing. Which I guess one way to do that would sort of make sense for our case would probably be if C3b vector was a type that we had, perhaps. Because I don't think, and we have vector 3 from libgdx, but I don't think we have vector 3b. I guess we could call it vector 3b. That's more consistent with this stuff. I don't care. Okay. C3b vector. Yeah, you know what? Sure. Let's call it vector 3b. That's more like how the Java guys are doing over here with vector 3. Okay. Vector 3b, right? So it's a 3-component byte vector. I'm almost sure that's what that has to be. So then, you know, read vtnr. So obviously this thing returns the data. Right, and so we return data. Now you could imagine an expressive language might let you swap out float, but we'd have to do Java generic, so we don't want to do that. So yeah, we're just going to have read vtnr vector 3b. Vector 3b, which means, by the way, I guess components is what's inside of vector 3b. We'll see about that. But yeah, so read vtnr vector 3b. Basically, I guess this doesn't need to be here. Let's see, vector 3b, vector 3b, vector 3b. Yeah, pretty much just all these. Pretty much just replace all of them. Cool. And I guess this is where you have another problem, that for in I equals 0, I less than row dot length, I plus plus, it's like I'm going to say row dot components yeah, reader uint8. Okay, uint8 array. Int8 array, row components. Ta-da! Okay, cool. So vtnr vector 3b. So basically, weirdly, and I don't think we want to have vtnr function anymore. Yeah. Read vtnr float, reader is alpha, becomes height map, which I guess is just a member variable. And then we want to do the same thing down here, read vtnr vector 3b, and this is the normals. And then yeah, we do the same thing with mcal over here. But instead of that, we want reader.read a uint32 array whose size is size alpha divided by 4. And this is an allocating call, but that's okay. This is alpha maps. Cool. Okay, create field alpha maps. Nice. Look at that. Alpha maps. Now, CLY over here, texture layers, you have to think about, what is that? What is that? Okay, texture layers. Some other new type has to be introduced. We have to read an amount equal to the number of layers. How about that? This is not a very good, I don't know. I'm not sure I like this parser. I think that it would be smarter to be reading things by their length and then switching on the things that you see. I guess you can't always do that. The parser is actually insane. Okay, I think, yeah, maybe the parser is just actually insane. Okay. MCLY needs to be texture layers, which I don't even know what that is, but we need to read a number of them equal to the number of layers, which makes sense-ish. You know, like load dynamic objects. You ever think about how the only reason this isn't static is version? Yeah, it would be something like that. So we want something like that over here. I don't think this needs version. I'm not really sold that it needs to exist at all, I guess, because we'll probably have to change it. But something like this is going to have to happen for MCLY, which sucks. We'll get back to that one. Some of these others might be easier, though. So what about, you look at something like MCRF. MCRF, doodad references, just a bunch of integers. If n doodad refs is greater than 0, then reader.read uint32 array n doodad refs. Yeah, doodad references. And if n map object refs greater than 0, then reader.read unit32 array and map object refs. Okay, map object references. Cool, and those could be member variables. Awesome. So that one's straightforward, right? And it's the same kind of thing, similar to the alpha map over here, MCAL, MCSH for shadows, just the same idea, right? Shadows, size shadow divided by 4. Create this variable for that. So that should be fine. CLQ, okay. Liquid flag, select where flag okay. So presumably this is a really, snazzified way of, I'm guessing, get liquid flags. Yeah, he's just basically saying for any flag. From 0 to 4. He's like looping over is river, is ocean, is magma, is slime. It's like a way of avoiding just typing it out. Like if is river, read river. If is ocean, read ocean. If is magma, read magma. If is slime. Like, okay. I think there's a lot of people on the internet that when they encounter this aren't going to know how to read it. Although maybe, I guess they teach kids Python like that these days so to make it complicated. Okay, sure. Maybe I'm just behind the times. I don't feel like doing a select call just to read a couple of lines of binary. Sure. So MCLQ, I could do that. But I also need to figure out what an MCLQ class actually is. So we're back to what is the MCLQ class, which gives me back to what is the MCLY class. So the MCLY class, it's a bunch of junk. Okay, MCLY. Slowing us down for things that we hardly care about. Okay, MCLY. There's no way this is going to work in Warsmith. It just doesn't. It just doesn't. Okay, I got to take a break. Really, like a lot. Like a lot break, actually. Yeah, I gotta take a break. Okay. Have a good day. Next week, we'll probably finish it. All right, chums. Let's do some more
World of Warcraft editing. I'm listening to some music. I don't know if you guys can hear the music in the background, but I was looking at this a little bit more. So MCLY is a map chunk layer. We're going to read map chunk layers. We could try to get these flags in here. I don't know if we're going to do the flags right now. Let's do the flags later. Let's do the flags later. Alright, you know what? I'm listening to my stupid music. I'm going to turn it off. Okay, cool. So anyway, MCLY over here. We got to load MCLY. We're going to do this. And I think it should be as simple now as going back to our parser and saying that if we see MCLY, we're going to load it. Okay, sorry, the secondary parser. We're in the HDR parser? No, SYN. No, SYN is chunk info. Hold on. I gotta get my bearings again here. SYN is chunk info. CNK is chunk itself. CNK is what we're parsing right now, right? Okay. So in CNK, in chunk itself, it's just chunk, CNK. There's a layer, a chunk layer. So the only thing I did off screen when I just sat down was I made this map chunk layer class. It's the same as MCLI. I was just kind of trying to get going again. So in order to use that, we do need to parse, MCLY over here. It reads a number of them equal to n layers. So this is back to where I guess load dynamic objects shouldn't be copied into this file, but load dynamic and dynamic objects should be copied over. Something like that, which is again unfortunate that n dynamic objects thinks it needs a version number. We don't have that. I'm just going to put -1 in here. Okay, great. So load n dynamic objects where n is the number of layers. Load n dynamic objects, layers, map chunk layer, this new class I made. It's new function, binary reader, and then the number, which should be n layers. Awesome. So the only thing we're missing here is we need, which honestly, I should be making more things public. It saves me time. We're still at the investigatory stage. If you're trying to build a robust API, you probably want private variables, but if you just want to see if it works, map chunk layers. We're gonna master place private with public here pretty soon. Okay, so get the map chunk layers, MCLY. We already have MCRF. We're missing MCLQ and MCSE. Which, to be honest, I don't know. I guess we might want LQ. All right, let's try MCLQ. So we have MCLQ. Obviously, he does this 4 flags select and then parses an MCLQ. I'm inclined to think that I could just do this the way of map chunk. I guess we don't have num liquids. There's size liquid, but he doesn't use size liquid. He uses this kind of bizarre detection of liquid count over here. So we could do this, but I think essentially what he's doing is if, what is it? How do we, let's see, has liquids is based on flags. Okay, so this thing, instead of has liquid, it's basically the same check, but instead of has liquid, it's the various independent liquid checks, right? So if is river, and we have is river, is ocean, and each one calls the same function. That's really what he was doing. I'm being a little bit more dumb with it, then I don't have to bother to make select calls and whatever. Okay, river, ocean, magma, slime. Each of them can spawn an MCLQ, so then that means we need to have liquid layers or something, map chunk liquid layer, liquid layers, something like that, obviously. Oh yeah, you guys might not have been able to hear me very clearly either. All right, I'll put the mic back on. I'm really not sure if anyone's ever going to watch a YouTube video of this, but I'll put the mic back on. All right, map chunk liquid layer, a class which of course doesn't exist yet. So we need to go back in here, copy map chunk layer, and make map chunk liquid layer, which of course would be extremely similar, but probably totally different. A map chunk liquid layer, this guy calls MCLQ, which again, you know, what is all of this? So this is all crazy, but we'll get to that. What does the reading for this actually depend on? If we put it over here and we put this over here, we can get it to work. Map chunk liquid layer. So first off, we don't want any of that stuff. We want to say he starts off using something called C range. Can we say what that is? C range. It's probably in common. We saw that before. Structures common. C range. What is it? It is just a low and a high value as floats. Okay, sure. So literally like reader.read float. Min height, read float, probably max height. Sure. Okay, then we switch on flags, which points out so we want this thing to have a constructor that says like int water type flag, something like that, right? So the idea here is when we're reading this, we're going to switch on the water type flag, and one of the cases is chunk.flags. They're all private, aren't they? That's sad. Okay, chunk.flags. No. Chunk.flags. There's right here. It's public. It needs to be final. Okay. Chunk.flags.ocean has a different function than magma, has a different function than everything else. Okay. Everything else is default. Okay, great. So if it's ocean as SO-vert, otherwise it has SM-vert, otherwise it has this other thing. Okay. I guess we should go look at his read jagged array extensions file too. So we had readers extensions. No. He did have an extensions folder, right? Yeah, read jagged array is probably in here. Yeah, it has an X and a Y count, and if they're the same, yeah, it's just a square. It's a square. Okay, sure. X and Y count and they're square. Okay. So if it's ocean, I mean, maybe we can clean this up a little bit. It needs to have verts, but really, what do we do with flow v? Okay, that's just something it has to read at the end. All right, so we have these verts, overt, mvert, wvert. We have verts. What do we do with them? Jagged arrays. Okay, so we have these jagged arrays. You have the structures. I think what's missing here then is you look at this and think Java doesn't like this type of generality in the same way. You can do it, but it's kind of gross. It just leaves me wondering
Should I be trying to do this some other way? No, I guess not. Okay. So one thing I think would be cleaner, probably, would be if this thing was typed on some type, and so then if his vertices array, basically, verts was this two-dimensional array typed on a type for the map chunk liquid layer is generically typed on. That way, instead of using water type flags, we can actually have like an interface. It's like a programming idea, right? Vert reader. And so vert reader is something, I guess it shouldn't even be static. It can just be a vert reader. So vert reader is something who returns a T when given a binary reader. Parse. It takes a binary reader and returns a T. How about I don't do that? Okay. I guess vert reader is also generically typed on T. Sure. Okay. So this guy takes in, I guess at that point then it's a static interface, right? It's interesting that we can't actually make a whatever. Okay. So the thought process would be we'd have vert reader over here, but yeah, we'll get back to that. Yeah. So we need to define these vertex classes, right? We definitely need these. SWVert, which I guess has a byte depth, flow 0%, flow 1%, filler, and height. So one idea would be if we construct these from binary readers, then it becomes somewhat reasonable to think we can just say depth equals reader.read at 8. We do that for each of these. We populate the filler, and then we say height is the float. So I think that makes sense. And we can do that for SWVert. Now, SOVert appears to be really similar, but with different variable names. This is SWVert, SOVert, perhaps. Cool. And SOVert has different variable names. So it has the same thing, the same notion of depth, but it also has foam. It also has whatever this wetness is, filler, and height. And then we have SMVert. It's just totally different. And MVert is S and T in height, whatever that is. A little bit smaller structure. And then we also have SWFlowV, which seems to have a lot more stuff going on. And we have to look up C-sphere because someone thought that was a good idea. Okay. Velocity, amplitude, frequency, but also dir and a sphere. What is a C-sphere? Come on, guys. Common C-sphere. A center and radius. Okay, nice, nice. Cool. So for the most part, my thought process is this switching on water type could now be a function of like vert reader. But I guess maybe not, actually. Okay, sure, maybe not. So the vert reader could just be the constructors. So basically, the guy who calls into this from the chunk, he's trying to read these. He could pretty much say, where this was switching again on water type flag, I can probably just utilize the same information and say map chunk liquid layers dot add new map chunk liquid layer, who you think would have to have the type flag, but perhaps does not. Perhaps we do not need the water type flag, and instead the type will be this guy, which again, rivers and slime just use SWVert. And then we construct it from a vert reader. And so I think we pretty much just say SWVert new. And it should automatically read. But obviously, rivers and slime are SWVert. Ocean and magma are different. So SOVert and SMVert. And then we sort of just type things the way they need to be typed. And it just kind of comes together. So I think that makes sense, and that gives us the ability to actually read the C range and then read this jagged array of vertices. So again, vert equals new T99. Can I do that? Okay, so Java is like a broken language or something. Pretty sure you can do this. Yeah, it's pretty dumb. Okay, and then from there, I can just make a for loop. Verts.length, I++, for int j, j less than verts I.length, j++, verts ij equals vert reader dot parse on the reader. Blah, 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 and it populates it. I think that makes sense. And then, we also need tiles. So tiles has essentially the same problem. It becomes an 8x8 byte array, and then reader.read int 8 array of row, I think. Yeah, we just do that. Read them all. That should be fine. And then flow v's. All right, reader.read uint 32. And so we just create a field and flow v's, and then flow v's is 2 of them. Why is it 2 of them instead of the number of flow v's? That seems dumb. All right. Well, in the style of these other ones, let's have a constructor for swflowv, which basically says read float 32 array center radius is reader.read float 32. And then we'd read another one on the direction. And then we do that with the rest of these. Velocity, amplitude, and frequency. I think that makes sense. So now that we have that, we can definitely have flowv's array equals flowv's equals new flowv's array 2. Although maybe that's stupid. I guess I'm setting up the arrays in the parse function for this one. Oh, SW flow V. Sorry, yeah. So for some reason, it's 2 of them. Actually, yeah, I think I can just make this equal to an array that makes a new guy of reader. Oh, you can only use them in initializers. That's dumb. Okay. I have to do that syntax. Cool. And we do that twice. So we have 2 of them. Why? Why is a good question. Also, min height and max height should be fields, shouldn't they? And again, I have this idea. I'm waking up to the idea that everything should just be public. It's going to be easier to access. Our goal is to try to access the data. Cool. So that's MCLQ, which is another thing in the chunk figured out. But I don't think we have the whole chunk figured out yet. So what else is in the chunk? So we figured out MCLQ, right? MCSE, which is sound emitters. So those, it's a whole other type. Map chunk sound emitter. Sounds kind of brainless. Okay, how about similar to chunk info? I think this map chunk sound emitter is just, this is probably like something that we'll never use. There will probably not be sound emitters, but in case there are, I want to do that. And actually, I'm thinking to myself, does this when the chunk reads sound emitters? Yeah, it does end sound emitters. So I don't even think it needs to be a chunk. I think it can just be a block. I would delete all this other stuff. It's just basically a parse function and a type. And that's all I'm going to do right now. So reader.read uint32 again. Okay, sound point ID. You could imagine there's a lot of this brainless kerfluffle. Sound name ID. Still don't think we're going to use these. Okay. Okay. Pos float array 3. So of course then the reader. This is probably how I should have done the other one, but whatever. Read float 32 array to the position. Max distance is a float. All right, reader, read float max distance. Who knows? Maybe we will put these sounds in the world someday, and will thank me when we get there. But probably not. Because first, we just want to go to Eastern Kingoms. That's what we're doing. This is how you go to Eastern Kingoms. Who would have thought that the road to Eastern Kingoms would be so complicated? You know, there ought to just be an arrow pointing to the kingdom of Eastern Kingoms. That would have made more sense. Read uint 16. Start time. What time is this units in? That's a good question. End time. Mode. Group silence min. Group silence max. And then you think to yourself, why am I even typing this? Why play instances min? Play instances max. All right, let's create variables for this. This is just a lot of superfluous nonsense is what I'm looking at right here. Play instances min, play instances max, loop count min, loop count max. Okay, reader, read uint 8. No, read int 8. I don't know, sure, read int 8. Loop count min. Loop count max. And then 2 more of these U shorts, which gives us enter sound gap min. Definitely sounds like something we'll never use on War Smash. Enter sound gap max. Okay, great. Ba 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 ba. All right, look at that. And then we just mass replace private with public because I don't want to. I mean, I guess you could do getters, right? Okay, so this is inconsistent, but you could do that both ways, right? Just generate a bunch of public getters, whatever. I don't care. I don't think I'm ever gonna use that. Okay. Cool. So this is case IMCSE, in which case it's just basically a matter of load and dynamic thingamathings, sound emitters, map chunk sound emitter new, reader, and sound emitters. Okay, now the only problem there is we need one of these arrays, sound emitters, sound emitters, that is map chunk sound emitter. Okay, great. I will probably go on to never use that for the rest of my entire life. Okay, great. Sorry, I think my mic moved. Hopefully you guys can hear me. Cool. So Chunk is complaining about load and dynamic objects, and I wonder why. Map chunk sound emitters. What's the problem? Map chunk sound emitter new. So you would have thought that would have worked, but load and dynamic objects wants the thing to be a chunk, and I say why? Doesn't need to be a chunk. That's great. Okay, fixed that one pretty easily, didn't I? You know, like I was saying with these public-private fields. All right, here's an idea. Let's generate getters on this thing we're looking at right here. This seems like a good case of something to generate getters on, because we have a bunch of private stuff. Okay, so apparently the first set of this is all these constants, and that's stupid. I don't know why the computer would even suggest that. So obviously the computer's gone insane. We don't want getters on constants. But we should get getters on everything else. That sort of makes sense. Okay. Sure. So now we have our chunk concept, maybe. I wonder. So you think about this. This can load chunk info, CNK. What else do we fail to load? Let's run it again. Let's run it again. What else do we fail to load? You know, unknown chunk types. We're looking for unknown chunk type. Oh, there we go. Okay, so obviously we're reading CNK the wrong way. Case MCNK. So it seems that with MCNK we're not reading. Well, it seems that MCNK is missing entirely. MCNK. Where's ChatGPT when you need him? All right, MCNK over here. Cool. So case MCNK allows us to then say we want to load one of these. That in order to load one of these, in order to load an MCNK. Hey, I'm back, and I'm looking at how to load an MCNK. So the way to load an MCNK, it looks like, is probably whatever, you know, sort of you lose your train of thought and you come back to it, right? But an MCNK is a chunk, and a chunk has its own special function. So it's going to be really similar to load dynamic objects, but perhaps not totally. New chunk. Chunk equals new chunk read MDX size. Okay, great. So I think that makes sense, which makes me think that we probably want to have maybe get last tile header dot chunk. That's an idea for me. If I have last tile header, let's see if he can have a chunk. Chunk. Yeah, we'll put chunk on him. I think that makes sense. Okay, last tile header. If last tile header's chunk is last tile header chunk not equal null, then throw some kind of error. Because my thought process is we want to set last tile header chunk equals chunk. Yeah, chunk. Okay, terminate, run again. What could go wrong? Oh, row I is null. Okay. All right, so data. Oh, yeah, okay, this makes sense. Row I equals new vector 3D. Sure, Fine. Logical. Okay, what else? Out is null. Okay. Oh, that's a stupid one. Okay. Sure, they were supposed to be 3-component byte vectors. All right. Okay, so we splat after reading an MCNK, which is, you know, not really the worst thing. I think that worse things have happened. That's a little bit frustrating, but let's see. So we get into, we need a debugger on this, right? And you would think that a lot of these things would be really logical to parse, but we're probably missing something super obvious at the end of MCNK. Could be. Right, because we have this like read function that goes to these things. Well, okay, so it's not that. But that's a good point. So down here, it's not one of these, you know. This should not get something other than these in chunk. That makes sense. I wonder if that will. Will that explode on that? Oh yeah, okay. Yeah. Oh, it already is a Word3 ID. Yeah, okay, token. Explode on token. T-string. Okay, sure. Ah, but it's empty. We don't know what it is. Map chunk red tag plus token. Something like that, right? So MCVT, this helps us a lot. Now we know it's an MCNR that we're reading the wrong way. What's going on with MCNR? It's normals. Okay. I don't even remember parsing normals. Ah! Well, okay. So the vector read VTNR. So we have VTNR, but we're reading them of vector 3Bs. So obviously, it's really important that there are exactly 9 9s and 8 8s. So then you ask yourself, okay, so I have 4 9s here, and then I have 5 9s, and I have 8 8s. So that seems right. You know, it seems right. But what else could go wrong? 9 9s and 8 8s. Non-uniform array. Hmm. 9 9s and 8 8s. It must suggest that I didn't know how to parse the non-uniform array the right way, because I think after we read VTNR of normals, we just break. You know, you just continue. And I'm guessing that I do that. Yeah. So then you're back to, it's almost a given that my read VTNR is corrupted. And why is that? Why is my read VTNR corrupted, you know? You look at non-uniform array. I guess I was looking at this before. So it has a column count. And for everything in column count, well, that's kind of weird. So this is weird, right? Okay, so for every row count, we figure out column count. So there's 17 rows. But that makes sense. That's consistent, right? 17 rows. For every row, I read column count at that index. And read a bunch of columns. And where does that go wrong? Am I not correct about their vector 3B? I bet I'm correct about their vector 3B, right? Vector 3B. Yeah, byte array of size 3. Okay, so where are we going wrong? I have all these int 8 arrays. Now, obviously, it's a bit confusing that I used the integer or variable I in a different way than they did, but I think that's okay, because at the end of the day, they have records row count, and I have records row count, and there are 17 of them, which is the row count. And then for each of those 17 things, we read a structure array. How does this go wrong? Int before equals reader.position, int after before plus comma plus after. So when in doubt, if we try to get right about there, we should be able to print, what I thought I did versus what I actually did. Okay, so you can see these two numbers differ by a certain amount, and that certain amount can be computed with calculator app, but is probably somewhere in the realm of 400. 193,348. 435. So the question then becomes, 435 divided into 17 pieces is what? It's nothing. It's insanely broken. So that's some good information right there. That's partly where I went wrong, because it should have been the case that I read 17 things. Well, oh no, wait, the 17 things aren't all the same size. Okay, wait. So 435. So if I have 17 things, but 9 of them are of size 9 times 3, plus 8 things that are of size 8 times 3, I get 435. So what about that am I not understanding? Because this does seem to explode right after this, right? Yeah, we break the loop, we repeat. Token is MCLY. Oh, wait a minute, it's tricking us. It was MCLY, now it's nothing. Oh, okay. What was that thing in the parser? Remember that thing? I stopped and stared at it for a really long time, and I was like, this doesn't seem like it should be here. This one is not alpha, or token is MCRF, or token is MCLY. So it seems like MCLY read IFF chunk. So my understanding of read IFF chunk is not correct. Reversed is true. Okay, so that's also interesting. I forgot about the reversed part of this, but fundamentally, MCLY. Okay, so size less than 0 and not liquid. So then we're back here, but then token is messed up. This just seems wrong, it just seems wrong. How about if I change this not alpha to not alpha and the other stuff? Because I don't know what this is, but he had a not alpha in there, so that makes you think like maybe that would do it, Well, it still exploded. Okay, but let's see if we can find where it exploded. So we read the same amount of data here again. Let's go back around the loop. So now token is MCLY again. So if I skip this thing and I look at MCLY and I try to load number of layers as the number of chunks, where does that get me? Does that explode? MCRF? Can I do that? Nope. MCSH. Now MCSH seems to be workable. Then what? Oh yeah, okay. So what's the next tag? 0. It's messed up. So that sort of makes sense, I think, that where we're getting messed up is this insane parser jump in chunk reading. This sort of makes sense, right? So like there's this end position. It's super weird. What we need to do is reader dot position at the end position. That thing. And even if that has to be an integer, it just has to do that. Because then you could sort of imagine reading through multiples of these. Apparently not. All right. Interesting. So we actually have multiple chunks. Multiple chunks in sequence that don't appear to have independent chunk header thingamablings. So I was kind of hoping maybe they did. It looks like they don't. But they do have index X and Y, so you could imagine using that to put them in some kind of array, maybe. Maybe that would make more sense. That would probably make more sense. Yeah, I'm not super familiar with this format, so that makes sense, I guess. The chunks, let's just try to read them for now. We won't try to do anything smart with the index. So what I'm going to do instead of last tile header chunk is we're just going to have chunks as an array. Yeah, so we go up here, we delete chunk, and we're going to make a list of chunks. And that's going to end up probably bad, but actually I wonder if I should put them in the tile header. You know, so instead of chunk, this could be like list chunks. I have a list of chunks. I think that makes sense, right? List of chunks. And then we could actually say get last tile header dot chunks add chunk. Sure. So yeah, I don't know if that's like stupid or something. It's trying to like order them and what's in the file. But hey, let's see if we get to the end of the file parsing. This looks extremely promising. Look at that. Look at that. We think that we went through the entire file all the way to the end. And then I printed out all these SM area infos. I don't really know what they are, but maybe I don't really care. So that seems promising because this is starting to make it look like we're actually like loading a file or something. So let's turn off the parsing of SM area infos for a moment. I'm kind of interested if the ending of the parsing of the file is like some kind of read fail, or if it actually thinks we sort of read through the entire thing. It kind of seems to think that we read through the entire thing. So that seems sort of fun. What can we do with that? What can we do with that, right? Can we render it? Would be a good question. Or, you know, how many of the different components do we have? So if I put it in a debugger when I get to the end right here, we could try to look at inside of that map. What is this? We're just gonna skip that. Okay, inside of that, yeah, just skip that for now. I am gonna probably want to delete this before and after though. So yeah, we crunch through the entire map. We get to the end. Now we're like, okay, boom, I have a map. Now what's in this map? So tile headers. So there are a bunch of tile headers, and every tile header has a bunch of chunks. And so that seems like kind of interesting. Like perhaps good to know, you know, like tons of tile headers, tons of chunks. And I don't know, like, yeah, it becomes this interesting question, right? Like how do we shoehorn that into the War Smash terrain? We probably do not, at least not easily. So that becomes its own kind of weird effort that's probably non-trivial. Well, I'll get back to that. I think I need a break to celebrate this moment that I've run through the entire file with some loose understanding of reading what's in it, which means that I can, you know, export it to some other thing or loop over it or those sorts of things, which is a very good place to be. So I'm going to take a quick break.